The Ultimate Salesforce Data Cloud and Agentforce Architect Masterclass, 250 Production Incidents.
In the modern enterprise, the role of a Salesforce architect has shifted from managing static databases to orchestrating autonomous intelligence. This masterclass is a deep dive into the war stories of modern enterprises, 250 real-world production incidents, system failures, and architectural crises. We have designed this to prepare you for the highest levels of enterprise pressure, ensuring you can design, secure, and troubleshoot the most complex AI-driven ecosystems on the planet.
The two-part series roadmap. Here is how we divided those 250 production incidents.
To ensure absolute mastery of both the technical engine and the executive strategy, we have divided this masterclass into two deep dive videos. Part 1. The Technical Engine Production Incidents 1 to 130 deep dives into data cloud ingestion, Agentforce actions, multi-cloud orchestration, and the strict technical boundaries of the Salesforce platform. Part 2. The Enterprise Frontier Production Incidents 131 to 250, focusing on FinOps credit economics, the Einstein Trust Layer, global governance, AI DevOps Agent Ops, and high-level ROI strategy. Part 1 builds the foundation. Part 2 secures the enterprise. Let's begin Part 1.
Part 1. The Technical Engine and Platform Boundaries.
In this first video, we explore the core mechanics of a Salesforce Data Cloud and Agentforce architecture. We will cover 130 production incidents, focusing on how data flows, how autonomous actions are triggered, and what happens when the platform's native limits are pushed to the breaking point. This is the operational reality of building production-ready AI.
Part 1. Categories 1 to 10 130 incidents.
You will master the following 10 domains in this technical deep dive. Category 1. Agentforce Autonomous Action Failures 15 Production Incidents. Category 2. Data Cloud Ingestion API and Connector Failures 15 Production Incidents. Category 3. Customer 360 Identity Resolution Failures 15 Production Incidents. Category 4. Data Cloud Harmonization and Data Graph Failures 15 Production Incidents. Category 5. Zero Copy, BYOL and Federated Architecture Failures 15 Production Incidents. Category 6. Multi-Cloud Agentforce Orchestration Failures 15 Production Incidents. Category 7. Enterprise Performance and Platform Limit Failures 15 Production Incidents. Category 8. RAG, Vector Search and Unstructured Pipeline Failures 15 Production Incidents. Category 9. Omni-Channel Human in the Loop HITL Scenarios 6 Production Incidents. Category 10. Salesforce Platform Nuances and Core Boundaries 4 Production Incidents. 130 production incidents ahead. Let's dive into Category 1.
Category 1. Agentforce Autonomous Action Failures.
When you grant an AI the power to take action via invocable actions, the risk moves from wrong text to catastrophic business outcomes. This category explores what happens when Agentforce misinterprets instructions and executes high-risk transactions. We test your ability to design the guardrails that prevent autonomous chaos.
Category 1. Autonomous Action Production Incidents 1 to 15.
Here are the 15 production incidents covering autonomous reasoning and execution failures. Production Incident 1. Unauthorized refunds issued via invocable actions. Production Incident 2. CPQ discount bypass via Agentforce quote generation. Production Incident 3. Mass case closure due to sentiment misclassification. Production Incident 4. False fraud alert storm saturating MuleSoft gateways. Production Incident 5. Opportunity stage hallucinations skewing global forecasting. Production Incident 6. Duplicate account explosion due to data cloud search failure. Production Incident 7. Confidential data leakage via outbound email actions. Production Incident 8. Infinite flow recursion loops crashing the Async Queue. Production Incident 9. Reasoning failures based on stale data graph context. Production Incident 10. Outdated cadence execution in sales engagement. Production Incident 11. Cascading record deletions through chained apex triggers. Production Incident 12. Unauthorized SLA credit triggers during service peaks. Production Incident 13. Native approval process bypass on high-value quotes. Production Incident 14. Recursive agent-to-agent escalation deadlocks. Production Incident 15. Mass marketing consent violation and GDPR risk. Total 15 incidents for autonomous actions. Let's start with Production Incident 1.
Production Incident 1. Within 47 minutes of a peak hour deployment, a misconfigured Agentforce service agent issued $182,000 in unauthorized full refunds via Apex invocable actions across 3 global regions. The anomaly was only detected when the finance team flagged a sudden spike in payment gateway egress alerts. What is your containment and remediation strategy?
Answer: this is a critical failure in action guardrails and financial entitlement logic. I would handle this via a Tier 1 incident response. 1. Immediate containment. Instantly deactivate the Agentforce service topic and revoke the update permission on the Refund custom object for the Agentforce integration user to stop the financial bleed. 2. Root cause analysis. Analyze the Einstein trust layer audit logs to determine if the agent misinterpreted customer frustration as a signal to override financial thresholds in the prompt template. 3. Long-term hard validation. Refactor the underlying Apex invocable method to include a mandatory check against a max_refund_limit custom metadata type. If the AI requested amount exceeds this, the Apex must throw an exception to block the database commit. 4. Operational monitoring. Build a Tableau Pulse dashboard that monitors agent-initiated refund volume in real time, with an automated kill switch flow if refunds exceed $5,000 in any 10-minute window. Pro tip: never trust the LLM's reasoning engine to enforce a budget. In Salesforce AI architecture, the AI requests but the Apex enforces. Always hard code your financial boundaries into the code layer, where no hallucination can bypass them.
Production Incident 2. An Agentforce sales agent accidentally approves a 75% discount for a Tier 3 customer, successfully bypassing CPQ, advanced approval rules, and creating a financially unsustainable signed contract. Sales Operations reports that the quote status was moved to approved without any human intervention. How do you resolve this governance bypass?
Answer: this occurs when Agentforce updates fields that act as entry criteria for automation without triggering the UI-based validation. My remediation plan is: 1. Root cause. The agent was granted direct edit access to the discount field, and CPQ was configured to trust API-level updates without re-triggering the approval engine. 2. Immediate containment. Update field-level security (FLS) to make the quote status and discount fields read only for the Agentforce integration user, forcing all updates through controlled actions. 3. Long-term remediation. Implement a validation guard flow. The Agentforce agent writes its suggested discount to a staging field, which then triggers a standard Salesforce approval process that requires a sales manager's digital signature to move to the actual quote record. Pro tip: use shadow fields for AI inputs. Never let an autonomous agent write directly to fields that trigger financial or legal status changes. Always use a human-signed approval step as the final gate in the Salesforce platform.
Production Incident 3. An Agentforce service agent is found to be closing active service cloud cases prematurely because it misinterpreted a customer's thank you as a signal of resolution. CSAT scores dropped from 4.8 to 2.1 in 4 hours, as 1,200 customers had their issues closed without actual fixes. How do you resolve this?
Answer: this is an intent classification failure within the Agentforce topic. I would first refine the topic instructions to provide explicit few-shot examples of politeness versus resolution, ensuring the agent knows a thank you is not a close case command. I would then implement an asynchronous resolution confirmation flow where the agent must ask, "Shall I close this case?" before it can trigger the case update. To prevent a repeat, I would implement a reopen rate monitor. If the reopen rate on AI closed cases exceeds 15%, the system automatically reverts the agent to a draft mode for case summaries only. Pro tip: implement a soft close status. Instead of moving the case to closed, have Agentforce move it to resolved pending confirmation. This allows the customer 24 hours to respond before a standard Salesforce flow performs the final hard close.
Production Incident 4. A technical glitch in a data cloud data graph causes an Agentforce agent to trigger 5,400 false fraud alerts in 1 hour via MuleSoft external actions. The fraud operations queue is paralyzed, and MuleSoft API gateway saturation is causing 503 errors across the enterprise. How do you recover?
Answer: this is a mass execution event caused by poor semantic grounding. My recovery plan involves 1. Immediate containment. Manually disable the MuleSoft API gateway policy for the Agentforce service account to protect the external banking system from further saturation. 2. Root cause. A null value in the data cloud ingestion stream caused the grounding logic to default to risk equals high for any transaction with a missing timestamp. 3. Long-term remediation. Configure a rate-limiting policy in MuleSoft specifically for Agentforce, capping outbound requests to 100 per minute. Additionally, update the prompt template to only allow fraud escalation if the data cloud confidence score is above 0.95. 4. Monitoring fix. Implement anomaly detection alerts in MuleSoft Anypoint monitoring to trigger a PagerDuty alert if the Agentforce MuleSoft traffic spikes by more than 200% in a 5-minute window. Pro tip: always implement circuit breakers at the integration layer MuleSoft. If an autonomous agent attempts to call an external system more than X times in a defined window, the API should return a 429 too many requests to force the agent into a cooling-off period.
Production Incident 5. Sales leadership reports that quarter-end pipeline forecasting has become unusable after 14,000 opportunities were incorrectly advanced to proposal or price quote stage overnight by an Agentforce agent, triggering thousands of false big deal alerts to the CFO. What is your architectural fix?
Answer: this is a hallucination issue caused by poor grounding or context window bloat. I would resolve this using the following steps. 1. Root cause. The agent was given general knowledge permissions which allowed it to guess stage progression when actual activity timeline data was missing. 2. Immediate containment. Roll back the opportunity stage changes using a data loader export from the previous day's backup and temporarily disable the stage update action in Agentforce. 3. Long-term remediation. Implement evidence-based grounding. Modify the invocable action to require a source_ID like a specific email or meeting record. If the agent cannot find a specific record in data cloud confirming a verbal agreement, the Apex code must reject the stage update. 4. Governance fix. Update the topic instructions to use negative constraints explicitly telling the agent, do not update opportunity stage unless there is a meeting transcript confirming budget approval. Pro tip: hallucinations often occur when the agent is over-eager to be helpful. In your topic instructions, explicitly tell the agent, silence is better than a guess. If evidence is missing, the agent should do nothing and flag the opportunity for a human sales rep.
Production Incident 6. An Agentforce agent is found to have created 8,500 duplicate customer account records because it fails to recognize that the customers already exist in Data Cloud's unified individual profiles. This has fragmented the single source of truth across the global org. How do you realign the agent?
Answer: the agent is likely searching core CRM objects instead of Data Cloud DMOs. I would realign the architecture as follows. 1. Root cause. The agent was using a standard search account action which only looks at the local Salesforce database, missing the unified profiles in Data Cloud. 2. Immediate containment. Suspend the agent's create record permission and initiate a match and merge job in Data Cloud to clean up the 8,500 duplicates. 3. Long-term remediation. Replace the standard search with a custom invocable action that queries the unified _individual _ DLM first. The agent must find a unified ID before it is permitted to call the create action. 4. Governance fix. Implement match rule hardening in Data Cloud, adding fuzzy match on mobile phone and email to ensure the agent finds existing profiles even with slight variations in spelling. Pro tip: Data Cloud is the brain, but the agent often defaults to core CRM habits. Always ground your Agentforce account actions in the unified individual DMO to prevent the duplicate explosion that occurs when AI cannot see across the enterprise.
Production Incident 7. An Agentforce agent sent outbound emails to 500 VIP customers that included unmasked internal contract notes containing confidential pricing margins. This occurred because the Einstein trust layer's sensitivity filters were not configured for custom internal objects. How do you secure this data?
Answer: This is a failure of the data masking configuration within the Einstein trust layer. I would immediately update the trust layer policy to include custom rejects patterns that recognize internal margin codes and contractual shorthand. I would then refactor the Agentforce email action to include a pre-processing apex layer that strips any text from the internal notes field before passing the payload to the LLM. Finally, I would implement a human-in-the-loop requirement for any email generated from a VIP account record, requiring a 10-second manual review before the message leaves the Salesforce platform. Pro tip: the trust layer is excellent at catching PII, but it is blind to business confidential data. Use Prompt Builder to explicitly instruct the agent. Never include text from the internal comments field in any customer-facing communication, regardless of the prompt.
Production Incident 8. A recursive logic loop is detected where an Agentforce agent triggers a Salesforce flow, which updates a record, which re-triggers the Agentforce agent's topic criteria. This has caused 400,000 async executions in 20 minutes, crashing the org's async apex queue. How do you break this loop?
Answer: this is a classic recursive trigger problem amplified by AI speed. I would implement the following loop breakers. 1. Immediate containment. Use the Apex Flex queue to abort the queued jobs and immediately deactivate the triggering Salesforce flow. 2. Root cause. A missing decision element in the flow allowed it to resave the record even when no meaningful change had occurred, requalifying the record for the Agentforce topic. 3. Long-term remediation. Add a recursion guard checkbox field. Agentforce sets is _AI_processed__C equals true, and the flow only executes if the field is false. The field is then reset on a scheduled nightly batch job. 4. Governance fix. Update the flow to use advanced entry criteria is changed logic to ensure the agent only triggers on specific non-automated field updates. Pro tip: always differentiate your AI integration user. In every Salesforce flow or trigger, add a check. If user equals Agentforce integration user, then stop. This prevents your standard automation from fighting with your autonomous agents.
The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the Masterclass.
Production Incident 9. An Agentforce agent is taking incorrect renewal actions because it is grounded in a data graph that includes expired contract data alongside active data. The agent cannot distinguish between the two, resulting in 400 incorrect renewal notices sent to former customers. How do you fix the grounding layer?
Answer: this is a semantic grounding failure in Data Cloud. I would resolve this by cleaning the data graph as follows. 1. Root cause. The data graph was configured as a flat view that did not enforce a status filter, overwhelming the LLM's context window with irrelevant historical data. 2. Immediate containment. Pause the renewal action topic and run a data cloud query to identify all customers who received the incorrect notices for the legal team. 3. Long-term remediation. Modify the data cloud data graph definition to include a hard filter where contract_status equals active. This ensures the LLM never even sees the expired data. 4. Governance fix. Update the prompt template to include status grounding, adding a line. Only consider records where the end date is in the future. If a record is expired, ignore it. Pro tip: data graphs are flattened for the LLM. If you include expired and active records in the same graph, the LLM often sees them as one big pile of facts. Always pre-filter your data graphs at the data cloud level to keep the AI's context window clean.
Production Incident 10. An Agentforce sales agent is sending contract renewal emails using outdated 2023 sales engagement cadences instead of the new 2026 templates, causing significant legal confusion over current pricing. How do you update the agent's knowledge base?
Answer: this is a knowledge staleness issue. I would perform the following updates. 1. Root cause. The vector search index in Data Cloud was still pointing to a legacy SharePoint folder containing the 2023 templates, and semantic search was prioritizing them due to their higher relevance scores. 2. Immediate containment. Manually archive the 2023 templates in the source system and trigger a full re-index of the Data Cloud search index. 3. Long-term remediation. Implement metadata filtering in the Data Cloud search index. I would add a status field and update the prompt builder template to only retrieve documents where status equals current. 4. Governance fix. Modify the topic instructions to say, you are only permitted to use templates marked with the 2026_standard tag. If you cannot find this tag, do not draft the email. Pro tip: semantic search does not care about dates, it cares about meaning. If your old and new templates sound the same, the AI will flip a coin. Always use hard metadata filtering to force the AI to use the newest content.
Production Incident 11. An Agentforce agent triggers a delete record action on a customer account, which mistakenly fires a chained apex trigger that deletes all related opportunities, contacts, and historical case data. How do you prevent these cascading AI disasters?
Answer: this is a failure of impact analysis in the architectural design. I would resecure the platform as follows. 1. Root cause. The Agentforce integration user was granted modify all data permissions in a sandbox to prod deployment error, bypassing the destructive action guardrails. 2. Immediate containment. Instantly remove the delete permission from the Agentforce integration profile and initiate a metadata audit of all AI-accessible invocable actions. 3. Long-term remediation. Refactor the delete action into a soft delete flow. Agentforce can only set status equals inactive. A human administrator then reviews the inactive queue weekly to perform the actual hard delete. 4. Governance fix. Update the chained apex triggers to include a check. If userinfo.getName. Contains with Agentforce return to block AI-driven deletions of child records. Pro tip: AI should be additive, not subtractive. In 99% of enterprise scenarios, an autonomous agent should only have create and update permissions. Any delete action should be routed through a human in the loop screen flow.
Production Incident 12. An Agentforce service agent is found to be triggering unauthorized SLA credits for customers who complained about wait times, even if they didn't qualify. This resulted in $42,000 in unearned service credits in a single weekend. How do you enforce compliance?
Answer: the agent is prioritizing sentiment over entitlement logic. I would fix the compliance layer as follows. 1. Root cause. The agent's instructions were too broad be helpful to frustrated customers, and the invocable action did not verify the service contract before execution. 2. Immediate containment. Disable the issue credit action and pull a report of all credits issued by the agent for the finance team to audit. 3. Long-term remediation. Ground the agent in the service contract and entitlement objects. The agent must find a verified breach record in Data Cloud before the issue credit action becomes available in its reasoning engine. 4. Governance fix. Move the credit logic into a calculated insight in Data Cloud. The agent can only request a credit. the platform returns the $0.00 if the entitlement is not met. Pro tip: autonomous agents are prone to empathy traps. They want to resolve frustration. You must hard code your financial policies into the invocable actions, so the agent physically cannot offer more than the system allows.
Production Incident 13. Your organization uses a complex multi-step approval process for quotes. You discover that Agentforce is bypassing these steps by updating the status field directly to approved via an invocable action. How do you reestablish governance?
Answer: this is a governance bypass. I would resecure the approval chain using these steps. 1. Root cause. The status field was not protected by field-level security for the AI profile, allowing the agent to perform a direct write instead of a submit for approval. 2. Immediate containment. Lock the status field for the Agentforce profile and revert all AI-approved quotes to draft status for manual review. 3. Long-term remediation. Replace the update record action with a submit for approval invocable action. This triggers the standard Salesforce approval engine, where a human manager must still provide the final sign-off. 4. Governance fix. Add a Salesforce validation rule that prevents any record from moving to approved unless a specific system flag set only by the official approval process is present. Pro tip: if you want an AI to approve something, it should only be the first-level approver. Any high-value transaction must have a human in the loop at the final stage of the Salesforce approval process.
Production Incident 14. A recursive escalation storm occurs where your Agentforce service agent escalates a case to an external partner's AI chatbot, which then declines it and sends it back, causing a 1,200 message loop in minutes. How do you architect a storm shelter?
Answer: this is a multi-agent deadlock. I would implement the following architectural safeguards. 1. Root cause. Both AI systems were configured with always respond logic and neither had a state awareness of the other agent's identity. 2. Immediate containment. Manually disable the MuleSoft API gateway connecting the two systems and pause the Agentforce service topic. 3. Long-term remediation. Implement a stateful interaction log. If the last responder is an external bot, Agentforce must wait for a 60-second cooldown before it can respond again. 4. Governance fix. Add a max interaction counter to the case record. If the agent sees more than 3 escalations in 5 minutes, it must auto-pause and flag the record for a human supervisor. Pro tip: agent-to-agent communication is high risk. Always design a circuit breaker into your external actions. If the frequency of inbound and outbound messages for a single record exceeds a specific limit, kill the process automatically.
Production Incident 15. An Agentforce marketing agent incorrectly triggered a mass re-engagement journey for 500,000 customers who had opted out, resulting in 12,000 complaints and a formal GDPR inquiry within 24 hours. This occurred because the agent failed to check the consent DMO in Data Cloud. How do you resolve this?
Answer: this is a consent governance failure. I would immediately pause all active marketing journeys and run a Data Cloud audit to reconcile the opt-out records versus the consent DMO. To prevent a recurrence, I would re-architect the marketing action to include a mandatory consent filter at the Data Cloud level. The segment passed to the agent must be pre-scrubbed before the agent even sees it. Finally, I would implement a trust layer policy that blocks any outbound communication action unless a valid consent token is present in the grounding payload, ensuring the AI cannot reason its way around legal requirements. Pro tip: never let the AI reason about consent. Consent should be a hard filter applied at the Data Cloud ingestion or segmentation layer. If you leave it to the AI to decide who to email, you are one hallucination away from a massive regulatory fine.
Category 1 Conclusion: Mastering Autonomous Guardrails.
Architecting for Agentforce is a fundamental shift from building automation to designing governance. As we've seen in these first 15 incidents, the risks of autonomous failure, from $182,000 refund spikes to recursive logic loops, are managed not by restricting the AI's creativity, but by hardening the Salesforce platform itself. Mastery in this category means ensuring that every invocable action has a hard-coded financial boundary in Apex, and every autonomous reasoning path has a human in the loop safety valve. The goal is not to prevent the AI from acting. It is to ensure the platform remains the ultimate and final authority on business logic.
The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the Masterclass.
Transition from Category 1 to Category 2.
But even the most perfectly governed Agentforce agent is only as intelligent as the data feeding its reasoning engine. If the brain of your AI is the Agentforce reasoning layer, then the blood is the streaming data flowing through your ingestion pipelines. When ingestion fails, whether through CDC synchronization gaps, Kafka bottlenecks, or schema drifts, the AI begins to hallucinate or make high-stakes decisions based on stale, dangerous facts. We must now move from the actions of the agent to the engine room of the enterprise. Data cloud ingestion and connector architecture. Let's explore Category 2.
Category 2. Data Cloud Ingestion API and Connector Failures.
Data cloud is the heartbeat of Agentforce, but that heartbeat is only as steady as its ingestion pipelines. In this category, we move beyond simple sync errors into the world of high-scale architectural collapse, where streaming bottlenecks, schema drifts, and CDC synchronization failures lead to stale AI reasoning and massive organizational distrust. We test your ability to maintain data integrity when the enterprise pipeline is under extreme pressure.
Category 2. Ingestion and Pipeline Incidents 16 to 30.
Here are the 15 production incidents covering ingestion failures and pipeline disasters. Production Incident 16. Streaming pipeline latency spikes causing stale intent hallucinations. Production Incident 17. CRM connector bulk ingestion bottlenecks delaying territory alignment. Production Incident 18. MuleSoft direct synchronization failure leading to $340,000 in stale pricing. Production Incident 19. Delayed calculated insight refreshes breaking real-time AI segmentation. Production Incident 20. Duplicate B2C commerce events inflating revenue metrics by 40%. Production Incident 21. Event replay corruption destroying historical customer engagement context. Production Incident 22. Amazon S3 backpressure failures crashing the real-time ingestion buffer. Production Incident 23. Schema drift breaking the DSO to DMO mapping for S3 datasets. Production Incident 24. Malformed JSON payload in the Web SDK causing silent ingestion drops. Production Incident 25. Platform API throttling blocking real-time VIP telemetry ingestion. Production Incident 26. Partition imbalance causing inconsistent Agentforce regional response times. Production Incident 27. Marketing cloud batch ingestion failure causing a Black Friday CX meltdown. Production Incident 28. Event ordering inconsistencies corrupting Agentforce causal logic. Production Incident 29. Outage recovery failures causing stale DLO to DMO profile hydration. Production incident 30. Dead letter QDLQ explosions saturating upstream enterprise systems. Total 15 incidents for ingestion and pipelines incidents. Let's dive into production incident 16.
Production incident 16. High streaming pipeline latency is causing Agentforce to ground its responses in engagement data that is 25 minutes old. As a result, agents are attempting to upsell premium packages to customers who just canceled their service via the mobile app 5 minutes ago, leading to a wave of viral complaints. How do you optimize the pipeline?
Answer: this is a reasoning latency mismatch. I would resolve this by optimizing the pipeline and adding a last-mile check. 1. Analyze data stream lag. Use the data stream monitor in Data Cloud to identify if the lag is occurring at the ingestion API layer or during the DLO to DMO mapping transformation. 2. Implement a pre-flight check action. Update the Agentforce topic to include a mandatory Apex invocable action that performs a real-time call out to the core CRM case object to check for a cancellation status before any upsell action is permitted. 3. Tune the data graph. Refactor the data graph used for grounding to prioritize the last_engagement_ timestamp, ensuring the LLM identifies the 15-minute gap and adjusts its persona to a service-first tone. 4. Increase ingestion priority. Transition the cancellation event stream to a high-throughput partition to reduce the processing time within the Data Cloud streaming engine. Pro tip: streaming data is eventually consistent, not instantly consistent, for high-risk decisions like upselling versus retention. Never rely on Data Cloud alone. Always have Agentforce perform a last-mile check against the core CRM record to ensure it has the absolute latest status.
Production incident 17. During a mid-quarter territory realignment, a Salesforce CRM connector bottleneck caused a 6-hour delay in synchronizing 2 million account updates to Data Cloud. Agentforce sales agents, operating on stale territory data, assigned 400 high-value leads to the wrong account executives, causing internal sales friction and lost commission disputes. How do you troubleshoot the bottleneck?
Answer: this is a bulk ingestion failure. I would handle the remediation through these steps. 1. Root cause. The CRM connector was overwhelmed by the 2 million record bulk update, triggering concurrency limits on the Salesforce bulk API and causing Data Cloud to fall into a retry loop. 2. Immediate containment. Pause the lead assignment Agentforce topic and notify the sales leadership of the data staleness to prevent further incorrect assignments. 3. Long-term remediation. Transition the territory ID updates to a change data capture CDC stream rather than a bulk sync connector. CDC sends only the changed fields in real time, significantly reducing the payload volume and preventing connector saturation. 4. Governance fix. Implement lead rerouting logic. If Agentforce detects that a lead's territory data has a sync_pending flag, it must route the lead to a manual review queue instead of an automated AE assignment. Pro tip: the CRM connector is a batch tool at heart. For high-velocity updates like territory or pricing, always prefer CDC change data capture or the Ingestion API to ensure your Agentforce agents are not making career-impacting decisions based on 6-hour-old data.
Production incident 18. A MuleSoft direct for Data Cloud synchronization failure occurred during a global pricing push, causing Agentforce to issue $340,000 in incorrect quotes. The finance VP reports that the AI is using last month's price book because the synchronization failed silently without alerting the architecture team. How do you resync the enterprise?
Answer: this is a silent synchronization failure. I would execute the following recovery plan. 1. Immediate containment. Revoke the Agentforce agent's permission to call the generate quote action and put a banner on the sales console warning reps that AI pricing is currently offline. 2. Root cause analysis. Investigate the MuleSoft endpoint monitoring logs. I would look for an expired OAuth token or a named credential mismatch that caused the MuleSoft to Data Cloud handshake to fail during the pricing update. 3. Perform a force refresh. Trigger a manual refresh of the pricing data stream and use a calculated insight to compare the ERP source prices against the Data Cloud DMO to verify 100% parity before re-enabling the agent. 4. Monitoring fix. Build a staleness alert in Data Cloud. If the price_book DMO has not been updated in more than 24 hours, an automated platform event is fired to alert the DevOps team via Slack. Pro tip: MuleSoft Direct is a powerful abstraction, but it can hide errors. Always implement an application-level heartbeat. Have MuleSoft send a dummy health check record to Data Cloud every hour. If the record does not arrive, you know your sync is broken before your AI starts losing money.
Production Incident 19. A critical calculated insight refresh failure went undetected for 4 days, causing Agentforce to use stale churn risk scores for high-value clients. Consequently, 3,000 customers who recently exhibited negative sentiment were not offered retention incentives, leading to a 5% spike in churn. How do you prevent insight staleness?
Answer: this is a derived data failure. I would resolve this by shifting to real-time insights and better monitoring. 1. Root cause. The calculated insight CI was stuck in a processing state due to a massive increase in raw engagement data that exceeded the CI's standard processing window. 2. Immediate containment. Manually trigger an emergency refresh of the churn risk insight and update the Agentforce prompt template to prioritize current sentiment from the last 3 emails over the calculated risk score. 3. Long-term remediation. Transition the churn signal from a batch CI to a streaming insight. This allows the churn score to update incrementally the moment a negative interaction is ingested, rather than waiting for a 24-hour batch cycle. 4. Observability fix. Build a CI health dashboard in Tableau Pulse that tracks the last successful refresh for every architectural insight, triggering a high-priority alert if any CI is more than 6 hours old. Pro tip: calculated insights are batch-oriented. For time-sensitive strategies like churn retention, always use streaming insights or data graphs that can provide sub-minute updates to the reasoning engine, ensuring your AI is not making decisions based on last week's news.
Production Incident 20. A logic error in the B2C Commerce Cloud order ingestion pipeline caused duplicate events to be ingested for every customer purchase, resulting in a 40% artificial inflation of unified revenue metrics. The CEO presented these inflated figures to the board before the error was discovered. How do you recover data integrity?
Answer: this is a data redundancy failure. I would lead the following architectural recovery. 1. Root cause. The ingestion source failed to implement an idempotency key, causing retried requests during a network flicker to be treated as unique new transactions in Data Cloud. 2. Immediate containment. Pause the affected data stream and the revenue dashboard to stop the propagation of incorrect data into executive reporting tools. 3. Long-term remediation. Reconfigure the data stream to use the transaction_ID as the primary key for the DLO. I would then perform a full refresh to force Data Cloud to flatten the duplicates based on the unique ID. 4. Governance fix. Work with the legal and finance teams to issue a data correction report, using the data lineage feature in Data Cloud to prove exactly which records were duplicates and how the corrected figures were reached. Pro tip: always use idempotency keys at the ingestion layer. If you provide a unique external_ID in your JSON payload, Data Cloud will automatically handle the upsert logic, preventing the duplicate explosions that lead to embarrassing board-level reporting errors.
Production Incident 21. A data event replay was triggered to fix a minor historical error, but it accidentally corrupted the interaction history for 2 million customers by double-counting legacy engagements. Agentforce is now making loyalty reward recommendations based on 2 times the actual engagement. How do you roll back?
Answer: this is a replay corruption failure. I would execute the following data rollback plan. 1. Immediate containment. Deactivate the Agentforce loyalty topic and hide the recommended rewards component from the customer portal to prevent customers from redeeming unearned points. 2. Root cause. The event replay was configured to append instead of upsert, causing the system to treat historical records as brand new engagement events. 3. Long-term remediation. Use the Data Cloud data deletion tool to remove all records ingested during the replay window. I would then perform a clean re-ingestion with a strictly defined deduplication key based on the original interaction_ID. 4. Governance fix. Implement a staging data space. Never perform a mass event replay on your production customer 360 data space. Always test the replay in a separate data space first to verify the results. Pro tip: Data Cloud does not have a Control-Z for mass ingestion. Always take a metadata snapshot of your DMOs before a replay, and always validate a 1% sample of your unified individuals to ensure the calculated insights haven't been artificially inflated by the replay logic.
Production Incident 22. Your Amazon S3 Data Cloud connector is experiencing backpressure failures due to a massive surge in high-volume log data, causing the real-time ingestion buffer to crash. Agentforce, which relies on this data for system status updates, is now 4 hours behind reality. How do you resolve the saturation?
Answer: This is an ingestion buffer failure. I would resolve the backpressure through these architectural shifts. 1. Root cause. The S3 bucket was receiving 5,000 files per minute, exceeding the Data Cloud S3 connector's ability to poll and process the records, leading to a massive queue buildup. 2. Immediate containment. Update the S3 bucket configuration to batch the small log files into larger 100 megabytes files. This reduces the number of polling requests Data Cloud has to make, significantly lowering the overhead. 3. Long-term remediation. Transition from S3 polling to an ingestion API approach using MuleSoft. MuleSoft can act as a buffer, smoothing out the traffic spikes and pushing data to Data Cloud at a sustainable rate. 4. Performance fix. Implement object-level partitioning in the S3 bucket, for example, /YYYY or mm/dd/hh/. This allows the Data Cloud connector to focus only on the most recent folder, reducing the scan time for every ingestion cycle. Pro tip: High-frequency small file ingestion is the enemy of S3 connectors. Always compact your data at the source AWS Glue or Lambda into larger files before Data Cloud touches them. This reduces backpressure and ensures your AI has a sub-minute view of system status.
Production Incident 23. An unannounced schema change in the Enterprise Amazon S3 bucket schema drift caused the Data Cloud S3 connector to fail, resulting in 48 hours of missing customer data. Agentforce, lacking this context, began cold calling existing high-value customers as if they were new leads. How do you fix the drift?
Answer: This is a schema evolution failure. I would handle the remediation through these steps. 1. Root cause. The upstream data team renamed the customer_tier column to account_level without notifying the Salesforce team, causing the DSO to DMO mapping to fail silently. 2. Immediate containment. Pause the lead prospecting Agentforce topic to prevent further embarrassing calls to existing customers while the data is being corrected. 3. Long-term remediation. Update the data source object DSO in Data Cloud to include the new field name and remap it to the standard individual_DMO. I would then trigger a full re-ingestion of the last 48 hours to fill the data gap. 4. Governance fix. Implement a data contract in MuleSoft that validates the S3 schema structure before it reaches the Data Cloud connector, alerting the architecture team if a column name changes. Pro tip: Schema drift is the silent killer of AI trust. Never connect Data Cloud directly to a raw S3 bucket without a validation layer. Use a glue crawler or MuleSoft middleware to ensure any schema change is caught before it corrupts your data model.
The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
Production Incident 24. A malformed JSON payload in your Web SDK ingestion, caused by a new website update, has been failing silently for 3 days. Agentforce, which powers real-time website support, has been making decisions based on 0% new data, causing $200,000 in lost conversion opportunities. How do you detect silent failures?
Answer: this is an observability failure. I would implement the following health monitoring stack. 1. Root cause. The Ingestion API was returning a 202 accepted status gateway reach, but the asynchronous mapping was failing because the website update added a nested JSON object that the DLO didn't support. 2. Immediate containment. Immediately update the Ingestion API mapping schema in Data Cloud to accommodate the nested JSON and trigger a manual re-pull of the missed data via the SDK logs. 3. Long-term remediation. Build a data freshness dashboard in Tableau CRM that tracks records received versus records mapped. If the mapping success rate drops below 99%, an automated PagerDuty alert is fired. 4. Observability fix. Implement client-side validation in the Web SDK. The website should perform a schema check before sending the payload to Data Cloud, logging errors to an external monitoring tool like Datadog. Pro tip: 202 accepted only means Salesforce received the JSON. It does not mean the data was successfully mapped to your DMO. Always monitor the data stream refresh history for mapping failures to catch silent ingestion errors before they become multi-$100,000 conversion disasters.
Production Incident 25. Your enterprise VIP telemetry stream is being throttled at the Salesforce Ingestion API gateway due to a rate limit violation, causing 60% of real-time usage data to be dropped. Agentforce is now failing to detect critical system failures for top-tier clients. How do you resolve the throttling?
Answer: this is an ingestion throughput failure. I would resolve this by optimizing the payload strategy. 1. Root cause. The telemetry source was sending individual JSON events for every heartbeat, quickly exceeding the requests per second limit allowed by the Data Cloud Ingestion API gateway. 2. Immediate containment. Update the telemetry source or the MuleSoft middleware to batch the events into arrays of 100 records per request, reducing the total number of API calls by 90% while keeping data volume the same. 3. Long-term remediation. Evaluate the transition to Salesforce Private Connect to bypass the public API gateway limits and provide a dedicated ingestion pipe for high-volume enterprise telemetry. 4. Observability fix. Set up a platform event alert that triggers a Slack notification to the DevOps team the moment the Ingestion API returns a 4292 many requests error code. Pro tip: in Data Cloud, frequency kills, batching saves. Do not send 1,000 API calls with 1 record each. Send 10 API calls with 100 records each. This simple shift in ingestion architecture can prevent 90% of gateway throttling issues.
Production Incident 26. A partition imbalance in your Data Cloud Ingestion API has resulted in 20% of customer events experiencing a 30-minute delay, while the rest are processed in seconds. Agentforce is now providing inconsistent and contradictory answers to customers in the same region. How do you rebalance the stream?
Answer: this is a stream skew failure. I would optimize the partitioning strategy as follows. 1. Root cause. The Ingestion API was using region_ID as the partition key, but one specific region had 10 times the traffic of the others, causing that specific partition to lag significantly behind the others. 2. Immediate containment. Update the Agentforce topic to acknowledge the potential delay. For example, I'm still processing your latest activity. If the last _engagement timestamp is found to be lagging by more than 2 minutes. 3. Long-term remediation. Change the partition key from a broad region _ID to a granular customer _UUID or a randomized shard ID. This ensures the ingestion load is evenly distributed across all available data cloud workers. 4. Monitoring fix. Use Tableau CRM to monitor ingestion lag by partition and configure an automated alert that triggers if any single partition's lag exceeds 60 seconds. Pro tip: partition skew is a common enterprise problem. Never use a high cardinality field like region or category as your primary partition key. Always use a unique ID or a hash to ensure your data cloud engine scales horizontally and provides consistent AI response times.
Production Incident 27. A batch ingestion failure from Marketing Cloud during a high-stakes flash sale caused a total CX meltdown when Agentforce offered sold-out items to 200,000 customers. The resulting order cancellations cost $4.2 million in potential revenue. How do you recover?
Answer: this is a high-velocity scale failure. I would implement the following emergency architecture. 1. Root cause. The Marketing Cloud ingestion was using a batch window of 60 minutes, which made the inventory data essentially useless during a flash sale where stock levels changed in seconds. 2. Immediate containment. Pivot the Agentforce shopping topic to a discovery-only mode, disabling all add-to-cart actions until the inventory data is verified through a real-time system. 3. Long-term remediation. Transition critical inventory data from batch ingestion to streaming ingestion via MuleSoft. I would also implement data graphs with real-time grounding for sub-second stock views. 4. Governance fix. Implement an inventory guardrail. If the last _stock _update is older than 5 minutes, Agentforce is forbidden from confirming a sale and must perform an external API call-out instead. Pro tip: Black Friday is the ultimate stress test. For fast-moving data like inventory, batch is your enemy. Always use streaming and real-time grounding for any data point that determines whether a customer can spend money.
Production Incident 28. A recovery process after a service outage failed to reprocess missed events in chronological order, leading to event ordering inconsistencies. Agentforce now believes customers have returned items before they purchased them, corrupting the AI's causal logic. How do you fix the lineage?
Answer: this is an event ordering failure. I would handle the recovery via these steps. 1. Root cause. The recovery process used parallel processing that did not respect the event timestamp metadata, causing out-of-order ingestion into the data model object's DMO. 2. Immediate containment. Pause all Agentforce return topics to prevent the AI from taking incorrect financial actions based on the corrupted chronological data. 3. Long-term remediation. Use the Data Cloud Data Deletion API to remove the out-of-order events. I would then perform a full re-ingestion using a single-threaded sequential process to ensure the purchase events are committed first. 4. Governance fix. Update the data model to include a sequence _ID from the source system and add a validation rule in Data Cloud that flags any return event that occurs before a corresponding purchase. Pro tip: AI models rely on causal logic A happen before B. When recovering from an outage, never use bulk upload unless you can guarantee the sequence. Always use the event timestamp as the primary sorting criteria to preserve the customer journey timeline.
Production Incident 29. Following a 12-hour data cloud outage, the outage recovery process failed to hydrate the unified individual profiles properly, leaving Agentforce with stale profiles. The AI is currently treating Diamond-tier customers as new leads. How do you restore profile integrity?
Answer: this is a profile hydration failure. I would execute a priority reconciliation plan. 1. Root cause. The outage recovery successfully updated the DLOs, but the identity resolution and data graph refresh jobs failed to trigger, leaving the unified individual records in a pre-outage state. 2. Immediate containment. Update the Agentforce topic to require a last_sync validation. If the profile's last_identity_refresh is older than 12 hours, the agent must perform an on-the-fly lookup via Apex. 3. Long-term remediation. Manually trigger a force identity resolution job for the entire data space. I would then monitor the unified profile count to ensure it aligns with the expected enterprise customer volume. 4. Governance fix. Implement an outage recovery runbook that includes a mandatory verification step for identity resolution and data graph status before AI agents are reactivated. Pro tip: profile hydration is a two-step process. Ingest data, then resolve identity. After an outage, the second step is often the one that fails. Always verify your unified individual refresh status before trusting your Agentforce agents to interact with VIPs.
Production Incident 30. A dead letter QDLQ explosion in an external system caused by data cloud rejecting 1 million malformed records has saturated the enterprise service bus, causing a cascading failure across the ERP. How do you stabilize the ecosystem?
Answer: this is an ingestion backflow failure. I would lead the following stabilization plan. 1. Immediate containment. Immediately disable the inbound connector to data cloud to stop the flow of malformed data and allow the external DLQ to be drained or purged. 2. Root cause. The external system was retrying 1 million malformed records every 60 seconds without a back-off strategy, overwhelming both the ERP and the Salesforce Ingestion API. 3. Long-term remediation. Implement schema validation at the source system. I would also configure a MuleSoft dead letter queue that captures rejected records and send them to a cold storage bucket for later analysis rather than retrying them indefinitely. 4. Governance fix. Establish a circuit breaker policy. If the ingestion API rejection rate exceeds 5%, the MuleSoft gateway must automatically open the circuit and stop all traffic to prevent cascading enterprise failures. Pro tip: dead letter queues are meant for troubleshooting, not as a secondary data store. Always implement exponential backoff and a max retry limit on your ingestion pipelines to ensure that a few malformed records do not bring down your entire enterprise supply chain.
Category 2 Conclusion. Hardening the enterprise pipeline.
Mastering data cloud ingestion is about moving from simple synchronization to resilient architecture. As these incidents demonstrate, the difference between a successful AI rollout and a multi-million-dollar PR disaster often comes down to how you handle schema drift, ingestion throttling, and event ordering. An architect's true value is not just in connecting the data. It is in building the observability, batching strategies, and circuit breakers that ensure the AI's reasoning blood remains pure, even when the enterprise source systems are under extreme stress.
The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
Transition from Category 2 to Category 3.
But even a perfectly tuned ingestion pipeline is useless if the data cannot be anchored to a single, verified human being. If ingestion is the blood of the system, then identity resolution is the identity, the ability to recognize that a website click, a mobile app purchase, and a service call all belong to the same person. When this layer fails, the AI begins treating your most loyal customers as total strangers, leading to fragmented journeys and broken trust. We must now move from the flow of data to the customer 360 and identity resolution layer. Let's explore Category 3.
Category 3. Customer 360 Identity Resolution and Profile Corruption.
Identity resolution is the most high-stakes configuration in Data Cloud. It is where raw data is transformed into a unified individual. In this category, we explore the identity crisis, those moments when match rules fail, survivorship logic overwrites critical data, and unified profiles become corrupted. We test your ability to maintain a single source of truth when millions of records from disparate systems are colliding in real time.
Category 3. Identity and Profile Incidents 31 to 45.
Here are the 15 production incidents covering identity resolution and customer 360 failures. Production Incident 31. False positive customer merges via loose data cloud match rules. Production Incident 32. Party graph and party role relationship corruption. Production Incident 33. Cross-brand identity collisions due to improper data space isolation. Production Incident 34. Fragmented unified individual profiles due to misconfigured fuzzy matching. Production Incident 35. Device ID and anonymous to known identity stitching failures. Production Incident 36. Conflict resolution failures in data cloud reconciliation rules. Production Incident 37. Orphan contact point records failing to link to a unified individual. Production Incident 38. Duplicate unified individuals, resulting from delayed identity resolution processing. Production Incident 39. Consent DMO mismatches across unified profiles. Production Incident 40. GDPR deletion propagation failures across data cloud. Production Incident 41. Incorrect survivorship rules overriding critical CRM source data. Production Incident 42. Identity graph inconsistencies between Sales Cloud and Data Cloud. Production Incident 43. Multi-region profile inconsistencies across distributed Salesforce orgs. Production Incident 44. Data Lake Object DLO lineage corruption causing untraceable identity merges. Production Incident 45. The $12 million profile merge incident. Total customer 360 corruption. Total 15 incidents for identity resolution. Let's dive into Production Incident 31.
Production Incident 31. A loose fuzzy match rule in Data Cloud caused a false positive merge where a high-value VIP customer's profile was unified with a flagged fraudster who shared a similar name and zip code. Agentforce, seeing the unified profile, granted the fraudster access to the VIP's restricted credit line, resulting in a $45,000 theft. How do you resecure the identity layer?
Answer: this is a match rule over generalization failure. I would handle the remediation through these steps. 1. Root cause. The match rule was configured with fuzzy name plus exact zip code without a unique identifier, allowing two distinct individuals to be treated as a single unified individual DMO. 2. Immediate containment. Instantly unpublish the identity resolution rule set and freeze the affected unified individual record to prevent further unauthorized transactions. 3. Long-term remediation. Implement multi-factor match rules. I would refactor the rule set to require at least 2 exact match criteria, for example, email plus mobile before a fuzzy name match is even considered. 4. Data cleanup. Execute a manual profile split via the Data Cloud API to separate the VIP and fraudster records, and use the identity lineage feature to identify downstream systems that receive the incorrect data. Pro tip: fuzzy matching is a dangerous luxury in high-stakes environments. Always use exact match for your primary identity resolution rules, and only use fuzzy as a secondary tiebreaker with a high threshold to prevent identity collisions.
Production Incident 32. A corruption in party graph logic caused Data Cloud to incorrectly group 4,000 unrelated customers into family profiles because they shared a common business address. Agentforce, attempting to be helpful, shared private order history across these unrelated individuals via the portal. How do you fix the graph relationships?
Answer: this is a party role relationship failure. I would resolve the data exposure as follows. 1. Root cause. The householding rule matched on street underscore address alone, ignoring the apartment or suite underscore number, which caused an entire office building's tenants to be merged into one household. 2. Immediate containment. Disable the Agentforce personalization topic and the customer portal data graph to stop the cross-exposure of private order history immediately. 3. Long-term remediation. Refactor the party graph to include relationship validation. I would implement a rule that requires a matching last name or account underscore ID in addition to the address before a household DMO is created. 4. Governance fix. Implement data spaces for different customer tiers. I would ensure that individual and household relationships are validated against a CRM source of truth before they are published to Agentforce. Pro tip: addresses are not unique identifiers. Always use a combination of address plus last name or address plus party underscore ID for householding logic to ensure you do not accidentally leak sensitive order data to strangers.
Production Incident 33. A global enterprise with 3 distinct brands experienced a cross-brand identity collision where customers from the economy brand were incorrectly merged with luxury profiles due to improper data space isolation. Agentforce began sending economy-tier discount codes to luxury VIPs, devaluing the brand and causing a $200,000 drop in high-margin sales. How do you isolate these identities?
Answer: this is a data space isolation failure. I would immediately implement data space isolation to ensure that each brand's data is processed within its own logical boundary. I would then update the identity resolution rules to include brand underscore ID as a mandatory exact match attribute, ensuring that a customer is only unified within their specific brand context. For the cleanup, I would use the identity lineage tool to identify every unified individual that contains data from multiple brands and trigger a re-resolution job to split them back into brand-specific profiles. Finally, I would implement a validation insight that flags any unified record that spans more than one brand underscore ID for immediate architectural review. Pro tip: in multi-brand environments, universal unification is often a mistake. Unless there is a specific global loyalty program, always use data spaces to keep brand identities separate and prevent high-value VIPs from being downgraded by economy-tier data collisions.
Production Incident 34. Misconfigured fuzzy matching has resulted in 1.2 million fragmented individual records where a single customer has 4 different unified IDs. Agentforce, unable to see the customer's full history, provided contradictory answers about their shipping status, leading to a 40% increase in support call volume. How do you heal the profiles?
Answer: this is a match rule under matching failure. I would heal the graph through these steps. 1. Root cause. The match rules were too strict: exact email plus exact phone, causing customers who used a different work email or a new mobile number to be treated as brand new individuals. 2. Immediate containment. Notify the Service Cloud team to use global search instead of Agentforce summaries for shipping status until the profiles are reunified. 3. Long-term remediation. Implement multi-step reconciliation. I would add a secondary match rule using fuzzy name plus mobile and a third rule using external underscore ID to bridge the gaps between legacy systems. 4. Governance fix. Configure reconciliation rules to prioritize the most recently updated source system, ensuring the unified individual displays current contact info while maintaining the link to historical IDs. Pro tip: fragmented identities are just as dangerous as false merges. Use the Identity Resolution Summary dashboard in Data Cloud to monitor your unification ratio. If the ratio is 1-to-1, your rules are too strict and your AI will be forgetful with your customers.
Production Incident 35. A failure in anonymous to known identity stitching occurred when 500,000 customers logged in, but their device IDs were not linked to their verified profiles. Agentforce, treating them as new strangers, offered welcome discounts instead of acknowledging their diamond tier status. How do you fix the stitching transition?
Answer: this is an identity stitching failure. I would resolve the transition as follows. 1. Root cause. The match rule for login_event was missing the external _ID mapping, causing the Web SDK to keep the anonymous cookie as the primary ID even after the user authenticated. 2. Immediate containment. Update the Agentforce web topic to include a session validation step via Apex to perform an explicit identity lookup by email, bypassing the data cloud cookie. 3. Long-term remediation. Refactor the identity resolution rules to include the party_identification_DMO. I would ensure the login_ID is mapped as a strong match to the individual_DMO, forcing an immediate profile merge. 4. CX fix. Implement real-time stitching alerts. If a customer logs in and their unified profile remains anonymous after 30 seconds, trigger an emergency refresh of that specific profile. Pro tip: the anonymous to known transition is the moment of truth. If your match rules do not immediately bridge the cookie ID to the Salesforce ID upon login, your AI will feel unintelligent to your most loyal users.
Production Incident 36. A failure in reconciliation rules caused duplicate golden records where one customer has two active profiles. Agentforce, seeing two different refund histories for the same person, accidentally issued a double refund to 500 customers across Sales and Service Cloud. How do you fix the conflict resolution?
Answer: this is a conflict resolution failure. I would consolidate the records as follows. 1. Root cause. The reconciliation rules were set to source system priority instead of most recent, causing two different systems to fight for identity and resulting in two separate unified IDs. 2. Immediate containment. Pause the refund action in Agentforce and run a report to identify all double refund transactions for the finance team's recovery process. 3. Long-term remediation. Refactor the reconciliation rules to use last updated as the primary survivorship criteria. This ensures the two source records are merged into a single golden record regardless of source system. 4. Governance fix. Implement data cloud data graphs for the refund action. I would require the agent to check the unified_individual_revenue_insight, which aggregates refunds across all IDs. Pro tip: golden records must be unique. If your sales and service data is not merging, your AI will treat the same customer as two people. Use last updated as your tiebreaker to ensure your customer 360 view is always singular.
Production Incident 37. You discover 800,000 orphan contact point records in Data Cloud that failed to link to a unified individual. Consequently, your Agentforce sales agent is failing to contact these leads, resulting in an estimated $50,000 in missed marketing ROI. How do you recover these orphan records?
Answer: this is a contact point mapping failure. I would first perform a lineage audit to identify which source system is sending contact points without a parent individual_ID. I would then implement a data prep job to synthesize a placeholder individual record for these orphans based on the email address, allowing them to be processed by identity resolution. To prevent a recurrence, I would add a mandatory field validation in the Ingestion API to ensure no contact point is accepted unless it is linked to a party ID. Finally, I would run an emergency unification job to see if these orphans belong to existing customers who were missing that specific email in their profile. Pro tip: orphans are dead data. In Data Cloud, an email address means nothing unless it is mapped to an individual DMO. Always monitor your orphan rate. If more than 2% of your contact points are unlinked, your AI agents are effectively blind to a portion of your database.
Production Incident 38. Due to delayed identity resolution processing, multiple duplicate unified individuals were created during a high-volume event. Agentforce, interacting with these duplicates simultaneously, issued conflicting service credits to the same customer. How do you handle the processing delay?
Answer: this is an IR processing race condition. I would lead the following architectural fix. 1. Root cause. The identity resolution job was set to a 24-hour frequency, and the real-time ingestion created new records faster than the unification job could merge them. 2. Immediate containment. Increase the identity resolution job frequency to hourly and implement a duplicate check apex action that Agentforce calls before issuing any financial credits. 3. Long-term remediation. Implement streaming identity resolution where available or use calculated insights to identify potential duplicates in real time, flagging them for the Agentforce agent. 4. Governance fix. Add a validation step to the credit action. The agent must verify that no other unified _ID with the same email address has received a credit in the last 60 minutes. Pro tip: identity resolution is often asynchronous. During high-volume windows, your unified individual count can temporarily spike. Always architect your Agentforce financial actions to look for fuzzy matches in real time to prevent double dipping while the IR job is pending.
The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the Masterclass.
Production Incident 39. A consent DMO mismatch occurred where an opt-out status was incorrectly reconciled during a profile merge. Agentforce began sending marketing emails to 12,000 people who had legally opted out, triggering a high-risk regulatory audit. How do you fix the consent mismatches?
Answer: this is a consent reconciliation failure. I would fix the logic through these steps. 1. Root cause. The reconciliation rule for consent_status was set to most frequent, allowing multiple opt-in records in the legacy system to outvote the opt-out in the web SDK. 2. Immediate containment. Instantly clear the marketing segments in Data Cloud and pause all outbound Agentforce communication topics to prevent further legal violations. 3. Long-term remediation. Update the reconciliation rule for consent_status to most restrictive. In this model, if any source system reports an opt-out, the unified profile must remain opted out. 4. Governance fix. Implement consent traceability in the trust layer, ensuring every AI-generated email includes a tag proving which source record was used to justify the communication. Pro tip: consent is the one field where most recent is not the answer. Always use a restrictive survivorship model for consent fields to ensure you never accidentally opt a customer during a profile merge.
Production Incident 40. Following a write-to-be-forgotten request, the customer's data failed to propagate across all data spaces due to a deletion propagation failure. Agentforce subsequently used that deleted data in a public response. How do you fix the propagation?
Answer: this is a multi-space deletion failure. I would lead the following architectural fix. 1. Root cause. The GDPR deletion workflow targeted only the default data space, leaving orphaned individual records in the analytics and training data spaces. 2. Immediate containment. Manually purge the affected customer ID from all data spaces using the Data Cloud API and notify the legal or privacy team of the breach. 3. Long-term remediation. Implement a global deletion orchestrator via MuleSoft. When a deletion request hits Salesforce, the orchestrator must call the delete API for every specific data space ID. 4. Governance fix. Build a deletion audit dashboard in Tableau that verifies the count of an ID is 0 across all DLOs and DMOs in every data space before closing the ticket. Pro tip: in Data Cloud, delete is not global across spaces. You must architect your workflows to iterate through every data space, or you risk zombie data resurfacing in your AI models and triggering fines.
Production Incident 41. Incorrect survivorship rules caused the unified individual to prioritize a 10-year-old work phone over a 2-hour-old mobile phone from the web portal, overriding critical CRM source data. Agentforce, attempting to send urgent SMS alerts, failed to reach 5,000 customers. How do you fix the rules?
Answer: this is a temporal survivorship failure. I would fix the prioritization through these steps. 1. Root cause. The reconciliation rule for mobile_phone was set to source system priority legacy equals 1, web equals 10, which prevented newer data from winning the golden record status. 2. Immediate containment. Perform an emergency update to the reconciliation rules, changing the criteria to most recent for all contact point fields. 3. Long-term remediation. Implement data quality scoring. I would assign a higher trust score to the web portal and mobile app for contact information, ensuring self-service updates always win. 4. Governance fix. Build a validation flow. If Agentforce detects an undeliverable SMS error, it must automatically flag the unified individual for a data reconciliation review. Pro tip: source system priority is great for birth dates, but terrible for mobile numbers. For contact data, always use most recent to ensure your AI is using the phone that is actually in the customer's hand.
Production Incident 42. An identity graph inconsistency between Sales Cloud and Data Cloud resulted in Agentforce providing conflicting loyalty balances to 2,000 customers. The agent was reading point balance from Sales Cloud while grounding in unified individual data from Data Cloud. How do you fix the inconsistency?
Answer: this is a source to unified inconsistency. I would resolve the conflict as follows. 1. Root cause. Sales Cloud had a local points field that was not being updated by the Data Cloud calculated insight due to a failed data action trigger. 2. Immediate containment. Update the Agentforce topic to only read the loyalty_balance from the Data Cloud DMO, ignoring the legacy field in Sales Cloud until the sync is restored. 3. Long-term remediation. Fix the data action in Data Cloud to ensure every CI refresh triggers a real-time update to the Sales Cloud record via the Ingestion API. 4. Governance fix. Implement field-level locking. Make the points field in Sales Cloud read only for all users, ensuring it can only be updated by the Data Cloud system user. Pro tip: avoid duplicate data where possible. If the data lives in Data Cloud, use a data graph or Lightning component to display it in Sales Cloud, rather than syncing it back to a custom field, which inevitably leads to data drift.
Production Incident 43. In a global deployment, multi-region profile inconsistencies resulted in a customer's unified profile in the EU being completely different from their profile in the USA. Agentforce provided contradictory answers to the same customer. How do you unify the global view?
Answer: this is a regional data silo failure. I would unify the global profile through these steps. 1. Root cause. The org used 2 separate Data Cloud instances for EU and USA due to data residency fears, and there was no global identity linkage strategy in place. 2. Immediate containment. Implement a global loyalty API via MuleSoft that queries both regional data clouds and performs a manual summation for the Agentforce agent. 3. Long-term remediation. Implement a global data space for identity metadata. While PII stays in the region, the unified_ID and loyalty_balance are synced to a central space for AI grounding. 4. Governance fix. Establish a global ID standard. Every customer must have a master ID that is consistent across all regional pods, even if their local data is stored separately. Pro tip: data residency does not mean you have to have split identities. You can keep sensitive data in Europe while syncing the global ID to a central space, ensuring your AI provides a consistent global experience.
Production Incident 44. A data lake object DLO lineage corruption caused untraceable identity merges where 50,000 customers were unified without a clear audit trail of which source record triggered the match. How do you restore the lineage and trust?
Answer: this is a data lineage failure. I would restore the auditability through these steps. 1. Root cause. A data prep transformation stripped the source_system_ID from the records before they reached the identity resolution engine, making the unified individual lineage blank. 2. Immediate containment. Pause the identity resolution job and export a snapshot of the current unified individuals to identify the scope of the untraceable records. 3. Long-term remediation. Refactor the data prep recipe to ensure the internal _organization_ID and source_record_ID are preserved and mapped to the individual _DMO. 4. Governance fix. Implement lineage validation. I would build a dashboard that flags any unified individual that has an unknown or empty source lineage for immediate architectural review. Pro tip: lineage is your security blanket in Data Cloud. If you cannot prove why two records merged, you cannot defend your identity resolution logic to auditors or angry customers. Always preserve your source IDs through every transformation.
Production Incident 45. The $12 million profile merge incident. A catastrophic error in identity resolution match rules caused 4 million unique customers to be compressed into just 150,000 monster profiles, destroying historical order history context. Agentforce sent sensitive statements to the wrong people. How do you recover?
Answer: this is a total identity collapse. I would lead the following high-stakes recovery. 1. Root cause. A developer pushed a match rule that matched on city plus country only, causing everyone in London, UK to be merged into a single unified individual. 2. Immediate containment. Emergency kill switch on all outbound communication and shut down the identity resolution job immediately to prevent further merging. 3. Long-term remediation. Perform a total data space reset. Use the delete API to wipe all unified individuals. I would then restore the individual DLOs and rerun identity resolution using a strict first strategy. 4. Governance fix. Implement identity guardrails. Build an automated check that triggers a shutdown if the unification ratio drops below a safe threshold, for example, if 4 million records become 150K. Pro tip: this is the nuclear option. Always have a metadata versioning strategy for match rules. Before pushing to production, always compare the predicted unified profile count against your current count to catch monster merges.
Category 3 Conclusion. The high cost of identity integrity.
Mastering identity resolution is the difference between a global customer 360 and a fragmented collection of data silos. As we have seen, a single loose match rule can trigger a $12 million profile collapse or a $45,000 theft. An architect's responsibility is to treat the unified individual not as a static record, but as a living, breathing identity that requires strict survivorship logic, restrictive consent models, and constant lineage auditing. When you secure the identity, you secure the foundation of all AI-driven trust.
The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
Transition from Category 3 to Category 4.
But identifying who the customer is only the first step. To take action, Agentforce needs to understand what the customer is doing and how their data relates to the enterprise model. This is where harmonization and data graphs come in. If identity is the who, then harmonization is the meaning. When your data graphs become stale or your DMO mappings drift, the AI loses its situational awareness, leading to garbage in, garbage out at an autonomous scale. We must now explore the engine of AI context, harmonization and data graphs. Let's dive into Category 4.
Category 4. Data Cloud Harmonization and Data Graph Failures.
Data graphs are the primary lens through which Agentforce views the customer. This category focuses on the contextual collapse, those moments when date formats break, currency codes fail to normalize, and stale graphs feed the AI outdated facts. We test your ability to build a robust, harmonized data model that can withstand the complexity of global enterprise operations.
Category 4. Harmonization and Data Graph Incidents 46 to 60.
Here are the 15 production incidents covering harmonization failures and data graph corruption. Production Incident 46. Date or time format corruption during DLO to DMO harmonization. Production Incident 47. Missing data model enrichment from third-party app exchange integrations. Production Incident 48. Stale data graph generation causing Agentforce to use old segment data. Production Incident 49. CRM payload synchronization latency breaking real-time prompt grounding. Production Incident 50. Einstein Studio predictive model inaccuracies due to poorly harmonized training data. Production Incident 51. Null value propagation across complex DMO relationships. Production Incident 52. Invalid ingestion of preference manager consent preferences. Production Incident 53. Currency, ISO code normalization, failures in global data cloud orgs. Production Incident 54. Time zone corruption affecting Agentforce time-sensitive reasoning. Production Incident 55. Duplicate engagement events inflating calculated insights metrics. Production Incident 56. Agentforce topics and actions trained on outdated Salesforce taxonomies. Production Incident 57. Broken streaming insights pipelines causing real-time alert failures. Production Incident 58. Incorrect field-level mapping in standard customer 360 data models. Production Incident 59. Partial data graph hydration failures during peak enterprise load. Production Incident 60. Trust layer audit scoring inaccuracies due to malformed payload metadata. Total 15 incidents for harmonization and data graphs. Let's dive into Production Incident 46.
Production Incident 46. A date or time format corruption occurred during the DLO to DMO harmonization of global weblogs, causing Agentforce to interpret 2026 events as occurring in 2024. Consequently, the agent ignored 5,000 real-time service requests as legacy data, resulting in an 18% spike in churn in 48 hours. How do you fix the harmonization mapping?
Answer: this is a temporal mapping failure. I would handle the recovery through these steps. 1. Root cause. The ingestion source sent dates in dd/mm/yyyy, but the data cloud DSO data source object was configured for mm/dd/yyyy, causing out-of-range errors and logical corruption. 2. Immediate containment. Pause the Agentforce engagement topic and use a data cloud formula to temporarily reparse the affected date strings until the DLO is re-ingested. 3. Long-term remediation. Perform a full refresh of the weblog data stream with a corrected source date format configuration. I would then update the DMO mapping to include a standardized ISO 8601 transformation to ensure consistency. 4. Governance fix. Implement mapping validation in the sandbox. I would create a unit test suite that validates 1% of all ingested payloads against the target DMO schema to catch format mismatches before they hit production. Pro tip: dates are the most common cause of AI hallucination in global orgs. Always use formula fields during harmonization to explicitly cast strings into a standardized UTC format before they hit your data model object's DMOs.
Production Incident 47. A critical missing data model enrichment occurred when a third-party app exchange credit scoring tool failed to map its data to the standard individual_DMO. Agentforce, blind to the customer's creditworthiness, issued $210,000 in high-risk loans to unqualified applicants. How do you re-enrich the model?
Answer: this is an enrichment mapping failure. I would resolve the gap as follows. 1. Root cause. The App Exchange package update renamed its custom objects, breaking the data connector mapping and causing the credit_score field in Data Cloud to remain null. 2. Immediate containment. Disable the Agentforce loan approval topic and implement a human review flag for all pending loan applications in Sales Cloud. 3. Long-term remediation. Remap the third-party DSO to the unified_individual_DMO using a calculated insight to aggregate scores. I would then perform an identity resolution refresh to ensure the new scores are linked to the unified profiles. 4. Governance fix. Implement null value circuit breakers. Add a validation rule to the Agentforce action. If credit_score is null, do not execute loan offer, route to credit department. Pro tip: third-party data is external context. Never allow an autonomous agent to take high-risk financial actions based on external data unless you have an enrichment validator like a flow that checks for data presence before the AI reasoning begins.
Production Incident 48. Stale data graph generation has resulted in Agentforce using 72-hour-old segment data during a fast-moving flash sale. Consequently, the AI sent limited time offers to 15,000 customers who had already redeemed their codes, leading to a massive spike in duplicate discount errors in the ERP. How do you fix the graph latency?
Answer: this is a graph refresh failure. I would handle the remediation through these steps. 1. Root cause. The data graph refresh frequency was set to once daily instead of real-time triggered, causing the Agentforce reasoning context to fall out of sync with the actual ingestion stream. 2. Immediate containment. Manually refresh the affected data graphs and update the prompt builder template to include a last_updated check on the segment data. 3. Long-term remediation. Transition the segment data from a batch segment to a real-time data graph grounded in streaming insights. This ensures that the moment a customer redeems a code, the data graph is updated for the agent. 4. Performance fix. Optimize the data graph by removing non-essential fields, reducing the payload size, and decreasing the refresh time for the reasoning engine during peak traffic. Pro tip: data graphs are the AI's eyes. If your business process moves in minutes like a flash sale, your data graphs cannot be updated in hours. Always use streaming insights as the trigger for data graph updates to ensure AI accuracy.
Production Incident 49. A 15-minute CRM payload synchronization latency occurred during a peak service window, breaking real-time prompt grounding. Agentforce, unable to see that a customer's case status had just been escalated, provided contradictory advice that led to a major contract cancellation from a VIP client. How do you recover?
Answer: this is a grounding staleness failure. I would resolve the inconsistency as follows. 1. Root cause. A high volume of concurrent CDC events caused the data cloud streaming buffer to hit its ceiling, delaying the availability of the new case status in the data graph. 2. Immediate containment. Update the Agentforce service topic to perform a real-time Apex call-out directly to Sales Cloud for case status, whenever the data cloud last_sync is older than 2 minutes. 3. Long-term remediation. Implement direct grounding via prompt builder. Instead of relying purely on data cloud for static facts, use a flow-based grounding to pull fast-moving CRM data in real time. 4. Governance fix. Establish a grounding SLA. If the data cloud sync latency exceeds 5 minutes, Agentforce must auto-switch to a safe mode where it defers to human agents for case status queries. Pro tip: data cloud is for deep context. The CRM is for immediate status. For mission-critical service interactions, always architect a hybrid grounding strategy that combines data cloud history with real-time CRM field values.
Production Incident 50. Cascading failure. Poorly harmonized return data in data cloud led to Einstein Studio predictive model inaccuracies, where the AI predicted a low churn risk for a VIP segment that was actually experiencing high return rates. Agentforce, trusting the model, ignored the segment, resulting in a $1.2 million revenue loss and a CFO-level audit of the AI strategy. How do you fix the predictive pipeline?
Answer: this is a garbage in, garbage out cascading failure. I would lead the following high-stakes recovery. 1. Root cause. The return_amount DLO was incorrectly harmonized as a positive value rather than a negative value, causing the Einstein Studio model to perceive returns as additional revenue. 2. Immediate containment. Immediately disable the churn prediction model in Einstein Studio and pause all Agentforce actions dependent on that score. 3. Long-term remediation. Correct the DMO harmonization logic. I would use a data cloud formula to ensure all return records are processed as negative integers. I would then retrain the Einstein Studio model using the corrected historical data. 4. Executive fix. Implement model observability. Build a dashboard that compares AI predictions versus real-world outcomes. If the variance exceeds 10%, the model is automatically flagged for architectural review. Pro tip: this is where harmonization hits the bottom line. If your data types are wrong, your predictions will be catastrophic. Always validate your harmonized data distributions mean, median, and max before using them to train Einstein Studio models.
Production Incident 51. A null value propagation failure occurred across complex DMO relationships, where a single missing product_category field caused Agentforce to fail all product recommendations for 200,000 customers. What is your architectural troubleshooting approach?
Answer: this is a relational integrity failure. I would resolve the propagation as follows. 1. Root cause. The data graph was configured with an inner join on the product DMO. When the category field was null for new products, the entire customer record was excluded from the graph. 2. Immediate containment. Update the data graph configuration to use left outer joins, ensuring that customer profiles are still available to the agent even if certain product metadata is missing. 3. Long-term remediation. Implement data cloud transformation data prep to populate default values, for example, uncategorized for any null fields during the ingestion cycle. 4. Governance fix. Implement null rate monitoring. Build an alert that triggers if the null rate on mandatory AI grounding fields exceeds 2%, signaling a source system data quality issue. Pro tip: in data cloud data graphs, joins matter. An inner join is a filter. Always use left joins in your graphs to ensure your AI agents have partial context rather than zero context when minor data gaps occur.
Production Incident 52. An invalid ingestion of Preference Manager consent data occurred, where a malformed API payload caused the consent_status DMO to be populated with garbage characters. Agentforce, unable to read the status, defaulted to opt-in and emailed 12,000 opted-out customers. How do you fix the consent harmonization?
Answer: this is a preference harmonization failure. I would fix the consent layer through these steps. 1. Root cause. The ingestion API was missing a schema validation step, allowing the preference manager to send legacy string data that did not match the expected Boolean DMO format. 2. Immediate containment. Immediately clear the marketing segment in Data Cloud and use a data action to set all malformed consent records to opt out by default for safety. 3. Long-term remediation. Implement a harmonization formula that maps any value other than true or active to a false status. This ensures a safe by default model for legal compliance. 4. Governance fix. Configure Preference Manager to use a standardized data contract with Data Cloud and implement a pre-flight validation flow in MuleSoft to catch malformed payloads. Pro tip: consent should never fail to opt in. For AI architects, the golden rule is, if the consent data is malformed or null, the answer is always no. Always use restrictive mapping for all preference manager DMOs.
Production Incident 53. A currency ISO code normalization failure in a global data cloud org caused Agentforce to treat Japanese yen JPY as US dollars USD. The AI issued $500,000 in incorrect discounts because it misinterpreted the purchase underscore value by a factor of 150. How do you fix the global normalization?
Answer: this is a currency normalization failure. I would handle the recovery as follows. 1. Root cause. The DLO to DMO mapping failed to specify the currency code source field, causing Data Cloud to default to the org's corporate currency USD for all incoming transactions. 2. Immediate containment. Disable the Agentforce discount topic globally and run a calculated insight to identify every customer who received an incorrect quote for the legal team. 3. Long-term remediation. Update the DMO mapping to include multi-currency normalization. I would use a data cloud formula to multiply the value by the exchange underscore rate DMO before saving to the unified record. 4. Governance fix. Implement ISO code validation. Build a dashboard that flags any transaction DLO where the currency underscore ISO underscore code is missing or does not match the standard enterprise list. Pro tip: global AI requires currency awareness. Never map amount fields without also mapping the currency code. Always use calculated insights to normalize all global revenue into a single corporate currency for the AI's reasoning engine.
The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the Masterclass.
Production Incident 54. Time zone corruption in the data cloud ingestion stream caused Agentforce to send urgent payment reminders at 3 a.m. to 10,000 customers. This resulted in a massive social media backlash and a 20% drop in mobile app ratings. How do you fix the temporal reasoning?
Answer: this is a temporal harmonization failure. I would fix the time zone logic through these steps. 1. Root cause. The ingestion payload lacked an offset, for example, to 5, and Data Cloud defaulted all timestamps to UTC, causing the AI to send messages based on the wrong local time. 2. Immediate containment. Pause the automated notification Agentforce topic and implement a human-friendly window filter in the prompt builder template, for example. Only send between 9 a.m. and 6 p.m. 3. Long-term remediation. Refactor the ingestion API to include the customer underscore local underscore time zone DLO. I would then use a data cloud formula to calculate the local _send time before triggering any AI action. 4. Governance fix. Implement time zone grounding in Prompt Builder. The agent must verify the customer's current local time from the data graph before it is permitted to call the send notification action. Pro tip: AI annoyance is a brand killer. Always harmonize your individual DMO with a time zone field. For enterprise AI, when you say something is just as important as what you say.
Production Incident 55. Duplicate engagement events from a misconfigured website tracker caused Data Cloud to double count every page view, artificially inflating calculated insights engagement metrics by 100%. Agentforce began flagging low-value browsers as VIP prospects, wasting 400 hours of sales rep time. How do you deduplicate the insights?
Answer: this is an engagement harmonization failure. I would lead the following recovery. 1. Root cause. The website web SDK was firing both a page view and a custom engagement event for the same click, and the data stream lacked a deduplication key. 2. Immediate containment. Pause the lead scoring calculated insight and the associated Agentforce topic to stop further false VIP alerts to the sales team. 3. Long-term remediation. Implement a deduplication logic in the data stream. I would use a composite key session _ID plus event _type plus timestamp to ensure that only unique engagement events are persisted in the DLO. 4. Governance fix. Update the calculated insight SQL to use a count with distinct event _ID instead of a simple the count function, ensuring that even if duplicates exist in the DLO, the AI's metrics remain accurate. Pro tip: engagement is easy to fake and hard to measure. Always use distinct counts in your calculated insights, and always implement idempotency keys at the web SDK layer to prevent your AI from being fooled by noisy data.
Production Incident 56. Agentforce topics and actions were found to be grounded in outdated Salesforce taxonomies, for example, using 2021 product categories, leading to the AI recommending discontinued products to 8,000 customers. How do you update the AI's product wisdom?
Answer: this is a taxonomy alignment failure. I would perform the following updates. 1. Root cause. The product DMO was harmonized using a legacy static mapping that hadn't been updated since the 2026 product catalog launch. 2. Immediate containment. Disable the Agentforce upsell topic and trigger a full resync of the product DLO from the master ERP system. 3. Long-term remediation. Implement dynamic taxonomy mapping. I would refactor the harmonization logic to pull category _name directly from the ERP data stream rather than using a hard-coded case statement in Data Cloud. 4. Governance fix. Implement a product lifecycle filter in the data graph. Any product with a status equals discontinued must be automatically excluded from the AI's context window. Pro tip: AI does not know what new means unless you tell it. Always harmonize your product DMO with an is_active or is_current flag. For an architect, old data is bad data when it comes to autonomous commerce.
Production Incident 57. A broken streaming insights pipeline caused by a high-frequency event storm prevented Agentforce from receiving real-time fraud signals. Consequently, the AI failed to block 1,200 suspicious login attempts, resulting in a series of account takeovers. How do you fix the streaming lag?
Answer: this is a streaming insight failure. I would resolve the lag as follows. 1. Root cause. The streaming insight SQL was two complex multi-level joins, causing the processing worker to crash under the weight of the event storm. 2. Immediate containment. Pivot the Agentforce security topic to a safe mode where it requires MFA multi-factor authentication for all logins until the streaming pipeline is stabilized. 3. Long-term remediation. Simplify the streaming insight SQL. I would move the complex historical context into a calculated insight and only use the streaming insight for immediate event recognition. 4. Performance fix. Increase the worker capacity for the Data Cloud streaming engine and implement event filtering at the Ingestion API to drop non-critical events during a storm. Pro tip: streaming insights are for speed, not complexity. If your SQL is more than 10 lines long, it belongs in a calculated insight. Keep your streaming logic lean to ensure your AI can react to security threats in sub-seconds.
Production Incident 58. Incorrect field-level mapping in the standard customer 360 data model caused Agentforce to swap personal email with work email for 50,000 customers. The AI began sending work-related alerts to personal addresses, violating company privacy policies. How do you fix the mapping drift?
Answer: this is a harmonization logic failure. I would fix the mapping through these steps. 1. Root cause. The data mapping interface was used to map email_1 from the source to work_email in the DMO, but the source system had swapped those fields during a database migration. 2. Immediate containment. Pause all Agentforce outbound email actions and trigger a recalculation of the unified_individual_DMO contact points. 3. Long-term remediation. Implement email type validation in the harmonization layer. Use a data cloud formula to inspect the domain, for example, @company.com, and dynamically map to work_email or personal_email regardless of the source column index. 4. Governance fix. Implement data quality auditing. Build a dashboard that flags any individual record where the work email domain is a public provider like Gmail, signaling a mapping error. Pro tip: never trust column index in source systems. Always harmonize based on data patterns. By using a formula to inspect the data before it hits the DMO, you can protect your AI from upstream database shifts.
Production Incident 59. Partial data graph hydration failures during a peak enterprise load caused Agentforce to see names but not purchase history for 100,000 customers. The AI, believing these were zero purchase customers, failed to provide loyalty support, leading to a wave of VIP complaints. How do you fix the hydration?
Answer: this is a graph hydration failure. I would resolve the partial load as follows. 1. Root cause. The data graph exceeded the payload size limit for the reasoning engine, causing the platform to truncate the related purchase records to save memory. 2. Immediate containment. Update the Agentforce loyalty topic to include a safety check. If purchase_history is empty, the agent must say, "I'm having trouble loading your full history. Let me check that for you," while it performs a real-time call out. 3. Long-term remediation. Refactor the data graph to use summarized metrics, for example, total_spend_last_90_days instead of raw transaction lists, significantly reducing the graph payload size. 4. Performance fix. Implement data cloud data graphs with filtering. Only pull the last 5 transactions into the graph, ensuring the AI always has the most recent context without hitting platform limits. Pro tip: data graphs have weight. If you try to feed the AI 1,000 raw transactions, the platform will choke. Always aggregate your data in Data Cloud before sending it to Agentforce to ensure 100% hydration success at scale.
Production Incident 60. Cascading failure malformed payload metadata caused Einstein trust layer audit scoring to fail, leading the system to believe that 100% of AI responses were safe when many contained toxic language. This resulted in a public PR scandal and a board-level ethics inquiry into the Salesforce AI rollout. How do you fix the trust scoring?
Answer: this is a metadata harmonization failure. I would lead the following architectural fix. 1. Root cause. The request_ID in the Agentforce payload was harmonized as a number instead of a string, causing the trust layer's asynchronous auditor to lose the link between the prompt and the toxicity score. 2. Immediate containment. Immediately shut down the public-facing Agentforce agent and pivot to a pre-approved template model for all responses until the audit trail is fixed. 3. Long-term remediation. Correct the metadata mapping in Data Cloud. Ensure that the prompt_ID and response_ID are harmonized as unique identifiers UUIDs across all DMOs and the trust layer audit objects. 4. Compliance fix. Implement red teaming monitoring. Build a dashboard in Data Cloud that cross-references trust layer toxicity alerts with user feedback. If the AI says safe but the user clicks thumbs down, trigger an immediate alert to the ethics committee. Pro tip: trust is not just about prevention, it is about auditability. If your metadata mapping is broken, your trust layer is useless because you cannot prove what happened after the fact. Always validate your audit trail lineage during your harmonization phase.
Category 4 Conclusion. The engine of AI context.
Mastering harmonization and data graphs is about ensuring the AI does not just see data, but understands business meaning. As we've seen, a single date format error or a misconfigured currency ISO code can trigger $500,000 in incorrect quotes or a total collapse of predictive trust. An architect's true skill lies in building a clean relational model where null values are trapped, time zones are normalized, and data graphs are hydrated with real-time precision. When the context is pure, the reasoning is flawless.
The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the Masterclass.
Transition from Category 4 to Category 5.
But in a modern enterprise, not all data lives inside Salesforce. The most valuable customer facts, like historical billing in Snowflake or deep telemetry in AWS Redshift, often remain in external data lakes. The zero-copy revolution allows Agentforce to reach into these lakes without the cost of HITL, but it introduces a new breed of architectural nightmares. Federated latency, egress cost explosions, and cross-cloud security inheritance failures. We must now move from the internal data model to the federated enterprise landscape, zero-copy and BYOL architecture. Let's explore Category 5.
Category 5. Zero copy, BYOL, and federated architecture failures.
Zero copy is the holy grail of data architecture, but it relies on a fragile handshake between clouds. This category explores the federated breakdown, those moments when Snowflake compute saturation, AWS governance conflicts, and iceberg table desynchronization turn your AI into a high-latency liability. We test your ability to manage data that you own but do not store, ensuring the cross-cloud bridge never collapses.
Category 5. Zero copy and federated incidents, 61 to 75.
Here are the 15 production incidents covering federated architecture and BYOL failures. Production Incident 61. Snowflake data shares zero copy latency causing Agentforce hallucination. Production Incident 62. BYOL bring your own lake governance conflicts with AWS Redshift. Production Incident 63. Data Cloud federated search failures against external Google BigQuery tables. Production Incident 64. Real-time BYOL query bottlenecks during high-volume interactions. Production Incident 65. Snowflake or AWS compute egress cost explosions triggered by Data Cloud Federation. Production Incident 66. Federated query consistency failures between Salesforce core and external lakes. Production Incident 67. Inconsistent snapshot synchronization in zero-copy architectures. Production Incident 68. Semantic layer mismatches between external Databricks and Data Cloud DMOs. Production Incident 69. Named credential and OAuth token expiration breaking zero copy mounts. Production Incident 70. Snowflake or Databricks warehouse concurrency saturation causing Agentforce timeouts. Production Incident 71. Cross-cloud caching inconsistencies via Data Cloud Data Federation. Production Incident 72. Apache Iceberg table synchronization issues with Data Cloud BYOL. Production Incident 73. Lakehouse row-level security inheritance failures when queried by Agentforce. Production Incident 74. Delta sharing corruption with external Snowflake objects. Production Incident 75. Real-time external warehouse scaling failures causing Agentforce action timeouts. Total 15 incidents for zero copy and BYOL. Let's dive into Production Incident 61.
Production Incident 61. A 12-second latency spike in the Snowflake data share caused Agentforce to timeout during a live customer interaction. The agent, failing to retrieve the customer's historical billing data via zero copy, hallucinated a zero balance and waived a legitimate $1,400 overdue fee. How do you fix the federated timeout?
Answer: this is a federated retrieval failure. I would handle the recovery through these steps. 1. Root cause. The Snowflake warehouse was in a suspended state and took too long to resume cold start, exceeding the Data Cloud federated query timeout limit of 10 seconds. 2. Immediate containment. Instantly update the Agentforce topic to include a retrieval guard. If the external billing DMO returns a null value, the agent must defer the answer. For example, I am retrieving your bill, rather than guessing a balance. 3. Long-term remediation. Transition the Snowflake warehouse to an always-on or pre-warm state during business hours. I would also implement Data Cloud data graphs to cache non-volatile billing metadata locally to reduce external query frequency. 4. Governance fix. Implement confidence scoring on federated fields. If the external query exceeds 5 seconds, the system should trigger a graceful degradation where Agentforce pivots to a human agent instead of risking a hallucination. Pro tip: zero copy is not zero latency. Never ground high-stakes financial decisions purely in an external federated table without a local cache or a strict timeout policy that prevents the LLM from filling the silence with hallucinated facts.
Production Incident 62. A BYOL governance conflict occurred when an AWS Redshift security update revoked the select permissions for the Data Cloud Service account. Agentforce, suddenly blind to 4 million records in the external lake, failed to generate Q4 renewal forecasts, resulting in a missed board-level reporting deadline. How do you resolve the conflict?
Answer: this is an identity and access management IAM failure. I would resolve the governance gap as follows. 1. Immediate containment. Manually trigger a Data Cloud data stream refresh to identify which specific federated DMOs are failing and alert the AWS Cloud Ops team to the IAM mismatch. 2. Root cause. AWS Redshift cluster implemented role-based access control RBAC that didn't recognize the Salesforce Private Connect principle, causing all federated queries to be rejected as unauthorized. 3. Long-term remediation. Implement credential rotation and access monitoring via MuleSoft. I would establish a cross-cloud service account with specific, least privileged federated query permissions that are excluded from automated security sweeps. 4. Governance fix. Establish a change management protocol between the data lake team and the Salesforce team. Any schema or permission change in Redshift must be pre-validated in a federated sandbox before being pushed to production. Pro tip: in a BYOL architecture, you are at the mercy of the lake owner. Always treat your external cloud credentials as a mission-critical dependency. Use Salesforce-named credentials with external secret stores to ensure your cross-cloud handshake never breaks during a security update.
Production Incident 63. A federated search failure occurred where Agentforce could not retrieve relevant contract clauses from external Google BigQuery tables during a legal audit. The architecture team discovered that the vector search index in Data Cloud was pointing to a stale metadata pointer, resulting in 0% search results for critical queries. How do you restore the search capability?
Answer: this is a federated metadata desync failure. I would immediately initiate a metadata refresh for the Google BigQuery federated DMO to resynchronize the schema and pointers. For root cause analysis, I would investigate whether the BigQuery partition scheme had changed, causing the data cloud search query to scan incorrect table shards. To prevent a recurrence, I would implement incremental indexing for the external lake and configure an alerting flow that monitors search success rates. If Agentforce returns 0 results for more than 5 consecutive high-confidence queries, the system must trigger an automated sync validation to check the BigQuery mount status. Pro tip: federated search is only as good as the metadata bridge. If your external lake BigQuery or Snowflake repartitions its data, your data cloud index becomes a map to nowhere. Always automate your metadata refreshes after any DDL data definition language changes in your external lakehouse.
Production Incident 64. During a high-volume customer appreciation event, real-time BYOL query bottlenecks caused a total collapse of the Agentforce personalization engine. The external data lake could not handle the 2,000 concurrent queries per second from Salesforce, resulting in 504 gateway timeout errors for 80,000 users. How do you recover?
Answer: this is a concurrency saturation failure. I would lead the following recovery strategy. 1. Root cause. The federated architecture was designed for analytics low concurrency, big data, but was being used for interaction high concurrency, small data, overwhelming the external lake's query coordinator. 2. Immediate containment. Activate emergency data ingestion. I would pivot the most critical 5 fields from federated or zero copy to physical ingestion in data cloud to reduce the external query load. 3. Long-term remediation. Implement federated query result caching in data cloud. This allows Salesforce to store the result of an external query for 15 to 30 minutes, preventing redundant hits to the external lake for the same customer. 4. Architectural fix. Negotiate an auto-scaling policy for the external warehouse, for example, Snowflake multi-cluster that specifically triggers when the Salesforce service account query volume spikes. Pro tip: zero copy is not a magic bullet for high-traffic apps. External lakes are designed for throughput, while Salesforce is designed for concurrency. For high-volume Agentforce agents, always cache your federated results to protect your external warehouse from a Salesforce-induced DDoS.
Production Incident 65. Cascading failure, an unoptimized federated query loop in an Agentforce sales agent triggered a $45,000 compute egress cost explosion in AWS in a single weekend. The AWS bill spike triggered an automatic budget freeze, which shut down the enterprise data lake, paralyzing the global sales team and stopping all real-time AI grounding. How do you fix the FinOps disaster?
Answer: this is a FinOps to operational cascading failure. I would execute the following high-stakes recovery. 1. Root cause. A recursive prompt caused Agentforce to query an external Redshift table for every word in its reasoning process, rather than performing a single batch retrieval of the customer context. 2. Immediate containment. Immediately unmount the AWS Redshift federated DMO and disable the external actions in Agentforce to stop the AWS credit burn while the budget is being renegotiated. 3. Long-term remediation. Refactor the prompt builder template to use data graph grounding. By pulling the data into a data cloud graph before the agent starts its reasoning, you ensure only one external query is made per interaction. 4. Governance fix. Implement egress quotas in data cloud. Build an automated monitor that alerts the CFO if federated query volume exceeds a predefined daily threshold, with a kill switch to protect the enterprise budget. Pro tip: zero copy creates a hidden financial bridge between clouds. If your AI is talkative with your data lake, your AWS or Snowflake bill will explode. Always ground your agents in data graphs to batch your federated queries and keep your egress costs under control.
Production Incident 66. Federated query consistency failures occurred where Agentforce provided different loyalty balances to the same customer within 2 minutes. The external Snowflake lake was still processing transaction batches, while the Salesforce CRM had already updated the point balance, creating a cross-cloud data drift. How do you resync?
Answer: this is a cross-cloud temporal consistency failure. I would resolve the drift as follows. 1. Root cause. Salesforce Core was using synchronous updates while the external federated lake was using asynchronous batching, resulting in a read after write inconsistency for the AI. 2. Immediate containment. Update the Agentforce loyalty topic to prioritize Salesforce Core fields as the source of truth for any transaction occurring within the last 24 hours. 3. Long-term remediation. Implement federated consistency logic. I would add a last_sync_ID to both systems. If the Snowflake ID is older than the Salesforce ID, the AI must ignore the federated data and rely on core CRM values. 4. Architectural fix. Transition the Snowflake integration from batch to continuous pipe snowpipe to reduce the cross-cloud latency from hours to seconds. Pro tip. In a federated world, consistency is your biggest challenge. Never assume your external lake is up to date with your CRM. Always build a version check into your AI reasoning to ensure it is not using last night's federated data to overwrite this morning's CRM facts.
Production Incident 67. An inconsistent snapshot synchronization in your zero-copy architecture caused Agentforce to offer restricted discounts to 4,000 customers who had already been flagged as ineligible in the external Databricks lake. This resulted in a $120,000 revenue loss and a compliance breach. How do you fix the snapshot sync?
Answer: this is a metadata snapshot failure. I would first perform a metadata audit on the data cloud data space to identify why the external table's last_modified flag failed to trigger a refresh of the Salesforce federated mount. I would then implement a mandatory cache invalidation flow that triggers every time a high-risk flag is updated in Databricks, forcing Data Cloud to drop its cached view and requery the lakehouse. To prevent future breaches, I would implement constraint-based grounding in the prompt builder, adding a line. If the federated _eligibility_status is unknown or older than 60 minutes, default to ineligible. This ensures a fail-safe security model for high-stakes discounts. Pro tip: zero copy often uses metadata caching to save compute costs. For compliance, heavy data like eligibility or credit status, you must disable caching or implement active syncing to ensure your AI is not making multi-thousand-dollar decisions based on a stale metadata snapshot.
Production Incident 68. A semantic layer mismatch between external Databricks and Data Cloud DMOs caused Agentforce to misinterpret lifetime_value LTV. Databricks calculated LTV including tax, while Data Cloud expected net revenue. The AI incorrectly granted Diamond status to 12,000 economy customers. How do you align the layers?
Answer: this is a cross-cloud semantic failure. I would align the models through these steps. 1. Root cause. The federated mapping was a simple column-to-field map that lacked a formula transformation, ignoring the underlying difference in business logic between the two platforms. 2. Immediate containment. Pause the Agentforce loyalty upgrade topic and trigger a data action to revert the 12,000 customers back to their correct tiers based on an internal SQL audit. 3. Long-term remediation. Implement a semantic transformation in the Data Cloud DSO data source object. I would use a formula to subtract the tax_amount from the raw_LTV before it is mapped to the DMO. 4. Governance fix. Establish a global data dictionary that defines every federated field's calculation logic. Any BYOL mount must pass a semantic certification where the Salesforce and Lakehouse architects verify the math is identical. Pro tip: zero copy does not mean zero logic. If your external lake calculates a metric differently than your CRM, your AI will be semantically confused. Always use Data Cloud formulas on your federated mounts to normalize business math across cloud boundaries.
The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
Production Incident 69. A named credential and OAuth token expiration caused all zero-copy mounts to break simultaneously during a quarterly sales review. Agentforce, unable to access the external AWS S3 market intelligence data, provided generic, outdated advice to 500 account executives. How do you restore the mounts?
Answer: this is a credential lifecycle failure. I would restore the connectivity as follows. 1. Root cause. The refresh token for the AWS service account was revoked by a corporate security policy that did not exclude service-to-service integrations from its 90-day rotation cycle. 2. Immediate containment. Manually reauthorize the named credential in the Salesforce setup and notify the sales team that external insights are being restored. 3. Long-term remediation. Transition from user-based OAuth to AWS Private Connect with IAM roles. This removes the reliance on expiring tokens and uses the underlying cloud trust relationship for permanent, secure access. 4. Monitoring fix. Build an integration health check dashboard. I would create an automated flow that performs a dummy query to each federated mount every hour, alerting the DevOps team if any mount returns a 401 unauthorized error. Pro tip: OAuth tokens are human-scale security. Enterprise AI needs cloud-scale security. For zero copy, always use private link and IAM role-based access service principles to ensure your AI is not fired just because someone's token expired.
Production Incident 70. Snowflake or Databricks warehouse concurrency saturation, caused by a 300% spike in Agentforce grounding requests, has triggered a total freeze of the enterprise analytics environment. The executive dashboard has crashed because the AI is stealing all available compute resources. How do you rebalance the warehouse?
Answer: this is a resource contention failure. I would resolve the saturation through these architectural shifts. 1. Root cause. Both human analysts and Agentforce agents were sharing the same large warehouse, and the AI's high-frequency small queries starved the long-running analytical queries. 2. Immediate containment. Immediately pivot Agentforce to a dedicated AI warehouse in Snowflake and implement a query limit on the Salesforce service account to prevent further saturation. 3. Long-term remediation. Implement multi-cluster auto-scaling for the AI warehouse. This ensures that as Agentforce traffic spikes, Snowflake automatically spins up additional clusters to handle the load without impacting the executive analytics. 4. Governance fix. Implement calculated insights in Data Cloud for high-frequency facts. Instead of querying the lake for every chat, pre-aggregate the data into Data Cloud once per hour to reduce external compute hits by 80%. Pro tip: AI is a resource hog. Never share a warehouse between your business intelligence team and your Agentforce agents. Always isolate your AI traffic into a dedicated, auto-scaling query engine to prevent your bots from bringing down your boardroom reports.
Production Incident 71. Cross-cloud caching inconsistencies resulted in Agentforce telling a customer their refund was processed, while the external ERP grounded via BYOL still showed the payment pending. This resulted in the customer spending ghost money and a $15,000 accounting imbalance. How do you fix the cache?
Answer: this is a distributed cache failure. I would resolve the inconsistency as follows. 1. Root cause. Data Cloud federated query caching was set to 60 minutes, causing the AI to read a stale success signal from the cache while the external lake had already rolled back the transaction due to a gateway error. 2. Immediate containment. Instantly clear the Data Cloud federated cache and disable read-only caching for the Refund DMO until the accounting team reconciles the ledgers. 3. Long-term remediation. Implement active invalidation. I would configure a Salesforce data action that sends a signal to clear cache for a specific unified individual ID whenever a financial transaction is updated in core CRM. 4. Governance fix. Update the Agentforce topic to include dual source verification. For financial summaries, the agent must check both the core CRM status and the federated lake status. If they do not match, the agent must escalate to a human. Pro tip: caching is for performance, but it is the enemy of accuracy. For any DMO that involves money or legal status, always set your cache TTL time to live to 0 to force a real-time cross-cloud query every time.
Production Incident 72. Apache Iceberg table synchronization issues with Data Cloud BYOL caused Agentforce to lose access to 48 hours of shipment data. The external lakehouse updated the Iceberg metadata pointer, but Salesforce was still looking at an old snapshot, resulting in 5,000 lost delivery updates. How do you resync the Iceberg mount?
Answer: this is a table format desync failure. I would handle the recovery through these steps. 1. Root cause. The external lake was performing compaction on the Iceberg tables, which changed the manifest file location, and the Salesforce zero copy connector failed to auto-discover the new manifest. 2. Immediate containment. Manually remount the Iceberg table in Data Cloud to force a metadata refresh and initiate a differential sync to capture the 48 hours of missed shipment data. 3. Long-term remediation. Implement Iceberg catalog integration, for example, AWS Glue or Snowflake catalog. By connecting to the catalog instead of the raw S3 manifest, Salesforce will always see the latest snapshot automatically after any compaction. 4. Monitoring fix. Build a snapshot latency alert. If the max_transaction_time in the federated DMO is more than 2 hours behind the current time, trigger a Slack alert to the data engineering team. Pro tip: Iceberg is a moving target. Never point Data Cloud to a static S3 manifest file. Always point it to a catalog service that manages the Iceberg snapshots, ensuring your AI agents never lose sight of the moving train that is your enterprise data.
Production Incident 73. A lakehouse row-level security RLS inheritance failure occurred where Agentforce, using the Salesforce service account, accidentally retrieved highly classified payroll data from an external Snowflake table. This data was then summarized in a public chat, violating HR privacy policies. How do you enforce RLS?
Answer: this is a cross-cloud security leak. I would lead the following architectural fix. 1. Root cause. The zero copy mount was configured with a super user Snowflake credential, and the row-level security policies in Snowflake were not designed to distinguish between human and service account queries. 2. Immediate containment. Immediately shut down the federated mount for the HR data space and purge the Agentforce reasoning logs to remove the leaked payroll summaries. 3. Long-term remediation. Implement external security policy mapping. I would refactor the Snowflake RLS policy to include a mandatory check. If current_role equals Salesforce_SVC_act, then apply _strict_filter. This ensures the AI can only see public data. 4. Governance fix. Implement trust layer PII scanning. Configure the Einstein trust layer to block any response containing salary or payroll keywords, providing a second layer of defense against cross-cloud leaks. Pro tip: zero copy does not mean security copy. Your external lake does not know what Salesforce permissions are. You must duplicate your security logic in the lakehouse to ensure your AI service account is strictly gated from sensitive enterprise data.
Production Incident 74. Delta sharing corruption with an external Snowflake object caused Agentforce to receive duplicate incremental updates for 1 million records. The AI, believing that customers had paid twice, triggered 1 million thank you emails for payments that never happened. How do you fix the Delta sync?
Answer: this is a Delta protocol failure. I would resolve the corruption through these steps. 1. Root cause. The Delta sharing protocol lost its checkpoint during a network timeout, causing Salesforce to re-request the last 24 hours of data that had already been ingested. 2. Immediate containment. Pause the payment notification Agentforce topic and use the Data Cloud data deletion tool to remove the duplicate payments based on the transaction underscore timestamp and unique underscore ID. 3. Long-term remediation. Transition from Delta sharing to zero-copy federated tables. Federated tables do not ingest data incrementally. They query it in real time, removing the risk of double ingestion during a checkpoint failure. 4. Governance fix. Implement idempotency in the AI action. The Agentforce agent must verify the email underscore sent underscore flag on the payment record before it is allowed to trigger a thank you communication. Pro tip: incremental sync is prone to double counting. For mission-critical communications, always use federated queries real-time instead of Delta sharing incremental to ensure your AI is always looking at the actual state of the lake, not a replay of the logs.
Production Incident 75. Cascading failure, a real-time external warehouse scaling failure during a regional AWS outage, caused Agentforce to time out for 50,000 customers. This triggered a support ticket storm that crashed the Service Cloud Omni-Channel routing, resulting in a total blackout of customer support and a viral PR disaster on social media. How do you recover?
Answer: this is a multi-cloud resilience cascading failure. I would lead the following recovery. 1. Root cause. The external lakehouse was located in a single AWS region that experienced a compute scaling outage. When Agentforce could not ground its responses, it defaulted to an error state, forcing 50,000 users to manually call support. 2. Immediate containment. Pivot Agentforce to resiliency mode. I would update the topic to use static fallback grounding using internal Salesforce data, only to provide basic answers and bypass the broken external federated lake. 3. Long-term remediation. Implement multi-region BYOL. I would set up a secondary data share in a different AWS or Azure region and configure a MuleSoft API gateway to failover to the secondary lake if the primary lake's response time exceeds 2 seconds. 4. Executive fix. Build a system resiliency dashboard for the CIO. I would prove that by having a local data cache in Data Cloud, the business can remain AI operational even during a total AWS or Snowflake regional outage. Pro tip: this is the architect's final exam. Never build a single point of failure in your zero-copy bridge. Always have a local fallback in Data Cloud that contains enough critical context to keep your AI alive when the external cloud goes dark.
Category 5 Conclusion. Bridging the cross-cloud chasm.
Zero-copy and BYOL architectures represent the ultimate freedom from HITL, but they demand a new level of architectural vigilance. As we have seen, mastering this domain is not just about the handshake. It is about managing federated query consistency, compute egress costs, and cross-cloud security inheritance. A principal architect ensures that the zero-copy bridge is built with local caching, strict timeout policies, and multi-region failover. When you control the federated layer, you turn the entire enterprise data lake into a real-time asset for Agentforce.
The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
Transition from Category 5 to Category 6.
But data is only as valuable as the actions it triggers across the enterprise. In a modern ecosystem, Agentforce does not just live in a single org. It must orchestrate complex workflows across sales, service, marketing, Slack, and external ERPs like SAP. This orchestration layer is where the happy path meets the reality of multi-cloud bottlenecks, API saturation, and recursive synchronization loops. We must now move from the storage of data to the orchestration of intelligence. Multi-cloud Agentforce workflows. Let's explore Category 6.
Category 6. Multi-cloud Agentforce orchestration failures.
Orchestration is the central nervous system of an AI-driven enterprise. This category explores the orchestration collapse, those moments when MuleSoft gateways saturate, cross-cloud contexts drift, and external model grounding fails. We test your ability to maintain a unified AI persona and a consistent business process as it travels across different clouds and external SaaS platforms.
Category 6. Multi-cloud orchestration incidents 76 to 90.
Here are the 15 production incidents covering multi-cloud orchestration and cross-platform AI failures. Production Incident 76. Agentforce context inconsistency between sales and service cloud consoles. Production Incident 77. Marketing Cloud advanced personalization corruption via outdated data graphs. Production Incident 78. MuleSoft endpoint orchestration bottlenecks blocking Agentforce external actions. Production Incident 79. Zero-copy federated query failures with external SAP HANA ERPs. Production Incident 80. Agentforce external actions timing out due to AWS Lambda cold starts. Production Incident 81. Azure OpenAI BYOL grounding failures in Einstein Studio. Production Incident 82. Slack Agentforce app workflow mapping incidents. Production Incident 83. Tableau Pulse semantic mismatches when querying data cloud insights. Production Incident 84. Platform event bus failures breaking Agentforce asynchronous actions. Production Incident 85. MuleSoft API gateway saturation caused by Agentforce reasoning loops. Production Incident 86. CRM to ERP synchronization loops triggered by autonomous Agentforce updates. Production Incident 87. Hyperforce failover inconsistencies disrupting grounding against BYOL endpoints. Production Incident 88. Real-time MuleSoft orchestration deadlocks in high-volume environments. Production Incident 89. Third-party SaaS grounding corruption via external services. Production Incident 90. Multi-org data cloud consolidation conflicts across global business units. Total 15 incidents for multi-cloud orchestration. Let's dive into Production Incident 76.
Production Incident 76. A context inconsistency between the sales and service cloud consoles caused Agentforce to provide contradictory answers to a VIP customer. The sales agent was grounding in open opportunities, while the service agent was grounded in recent escalations, resulting in the AI offering an upsell while the customer was still in a critical outage state. How do you unify the cross-console context?
Answer: this is a cross-cloud context drift failure. I would resolve the inconsistency as follows. 1. Root cause. The two Agentforce agents were using different data graphs, one optimized for sales and one for service, which lacked a shared global sentiment DMO to act as a unified guardrail. 2. Immediate containment. Update the Agentforce topic instructions across both consoles to include a cross-cloud priority check. If an active case exists with a high priority, The agent must disable all sales topics automatically. 3. Long-term remediation. Implement a unified customer 360 data graph that is shared across all Agentforce agents. This graph must include a system-wide status flag that is updated in real time by both sales and service events. 4. Governance fix. Establish a cross-cloud persona standard. Use Prompt Builder to ensure that regardless of the console, the agent first queries the unified engagement DMO to determine the customer's current emotional and operational state. Pro tip: context is not org-specific in the eyes of the customer. For a truly intelligent Agentforce deployment, always ground your agents in a unified data graph that spans all clouds, ensuring your sales brain knows exactly what your service brain is doing.
Production Incident 77. A Marketing Cloud Advanced Personalization corruption occurred where outdated data graphs caused Agentforce to send premium product recommendations to 200,000 customers who had just downgraded their service. This resulted in a massive spike in marketing fatigue and a 12% drop in email open rates. How do you refresh the personalization context?
Answer: this is a marketing to data cloud synchronization failure. I would handle the recovery through these steps. 1. Root cause. The data cloud to marketing cloud data action trigger failed, causing the segment membership in marketing cloud to remain stale while the actual tier in data cloud had changed. 2. Immediate containment. Immediately pause the marketing cloud journey and use the segment filter to exclude any customer whose last _updated timestamp in data cloud is more than 24 hours old. 3. Long-term remediation. Refactor the integration to use streaming data actions. This ensures that as soon as a tier change DMO is updated in data cloud, it triggers an immediate injection into the marketing cloud journey. 4. Governance fix. Implement segment validation. Build a dashboard that compares data cloud segment membership versus marketing cloud subscriber status to identify and alert on any cross-cloud drift. Pro tip: advanced personalization requires real-time precision. Never rely on nightly batch syncs for marketing cloud journeys. Use streaming data actions to ensure your Agentforce personalization is always grounded in the customer's current status.
Production Incident 78. During a high-volume promotion, MuleSoft endpoint orchestration bottlenecks blocked Agentforce from calling external actions in the ERP. The AI, unable to verify shipping costs, defaulted to free shipping for 15,000 orders, costing the company $180,000 in unrecovered logistics fees. How do you resolve the orchestration bottleneck?
Answer: this is a MuleSoft throughput failure. I would immediately implement vertical scaling for the MuleSoft workers vCores to increase the concurrency of the shipping API wrapper. For root cause analysis, I would investigate the thread dump in Endpoint Runtime Manager to see if synchronous callouts to the legacy ERP were causing a thread exhaustion deadlock. To prevent a recurrence, I would refactor the orchestration to use asynchronous callbacks. Instead of Agentforce waiting for a real-time shipping quote, the agent should submit a request, and a separate MuleSoft triggered platform event would update the quote record once the ERP responds. Finally, I would implement MuleSoft rate limiting to protect the legacy ERP from being overwhelmed by AI-generated traffic during peak windows. Pro tip: AI moves faster than legacy ERPs. Never architect Agentforce to perform synchronous orchestration with slow back-office systems. Use asynchronous event-driven architecture with platform events to ensure your AI agents do not give away the store when the middleware becomes a bottleneck.
Production Incident 79. Cascading failure, a zero-copy federated query failure with an external SAP HANA ERP caused Agentforce to fail all order status queries for 48 hours. This triggered a support call storm that overwhelmed the Service Cloud SOC, causing a supply chain gridlock and a board-level escalation regarding the failure of the autonomous enterprise strategy. How do you fix the SAP bridge?
Answer: this is a federated to supply chain cascading failure. I would lead the following high-stakes recovery. 1. Root cause. The SAP HANA OData endpoint changed its authentication protocol, causing the data cloud external data source to lose its mount while the metadata still appeared as active. 2. Immediate containment. Pivot Agentforce to CRM-only mode. I would update the topic to ground only in Salesforce internal order history, while alerting the customer that live ERP status is currently unavailable. 3. Long-term remediation. Re-establish the SAP zero copy mount using mutual TLS/MTLS for permanent, secure connectivity. I would then perform a lineage resync to ensure all SAP grounded DMOs are once again hydrated. 4. Executive fix. Build a cross-cloud health dashboard. I would prove to leadership that by having a MuleSoft API resiliency layer between SAP and Salesforce, the AI can fail over to cache data during an ERP outage. Pro tip: your AI is only as smart as its connectivity. For critical external systems like SAP, never point Agentforce directly to a raw endpoint. Always use a MuleSoft resiliency layer to provide caching and failover capabilities for your AI grounding.
Production Incident 80. Agentforce external actions were found to be timing out frequently due to AWS Lambda cold starts during the grounding phase. Customers experienced a 15-second lag in responses, leading to an 80% drop-off rate in the chat concierge. How do you resolve the cold start latency?
Answer: this is a compute latency failure. I would optimize the orchestration as follows. 1. Root cause. The AWS Lambda function responsible for retrieval augmented generation RAG was set to on demand, causing a 3 to 5 second delay whenever the AI had to wake up a new compute instance. 2. Immediate containment. Update the Lambda configuration to use provision concurrency, ensuring that a minimum of 50 instances are always pre-warmed and ready for Agentforce requests. 3. Long-term remediation. Refactor the Lambda code to reduce its deployment package size and move non-essential dependencies to Lambda layers, decreasing the initial boot time for any new instances. 4. Orchestration fix. Implement parallel processing in the Agentforce invocable action. Have the agent trigger the Lambda retrieval and a Salesforce search simultaneously, using whichever result returns first. Pro tip: in AI, milliseconds are money. If you are using AWS Lambda for your Agentforce external actions, provision concurrency is a mandatory architectural cost to ensure your AI feels real-time and does not lose customers during a cold start.
Production Incident 81. An Azure OpenAI BYOM grounding failure occurred where Einstein Studio failed to pass the contextual metadata to the external model. Consequently, Agentforce began providing generic, non-personalized advice to high-value banking clients, resulting in a 30% drop in lead-to-quote conversion. How do you fix the BYOM grounding?
Answer: this is a prompt orchestration failure. I would resolve the grounding gap as follows. 1. Root cause. The Einstein Studio configuration was missing the metadata mapping for the Azure API payload, causing the external model to receive the question, but not the customer context from Data Cloud. 2. Immediate containment. Switch the Agentforce agent to the standard Einstein model temporarily while the Azure API mapping is corrected in Einstein Studio. 3. Long-term remediation. Remap the model input in Einstein Studio to include the unified _individual DMO as a mandatory grounding object. I would then perform a model evaluation to verify that Azure is correctly interpreting the context. 4. Governance fix. Implement output validation. Build a prompt builder template that requires the model to cite its sources from the grounding data, ensuring it cannot provide a generic response without referencing the customer's facts. Pro tip: bring your own model. BYOM is powerful, but you must manually feed it. If you do not explicitly map your Data Cloud DMOs to your external model's input payload, your expensive Azure or OpenAI model will be flying blind within your Salesforce org.
Production Incident 82. A Slack Agentforce app workflow mapping incident occurred where the AI misinterpreted a channel's thread context, accidentally posting confidential contract negotiation notes into a public hash general channel. How do you resecure the Slack orchestration?
Answer: this is a channel-level security failure. I would resecure the Slack integration through these steps. 1. Root cause. The Agentforce action in Slack was granted broadcast permissions without a channel metadata check, allowing it to respond to sensitive queries in any channel it was invited to. 2. Immediate containment. Immediately deauthorize the Agentforce app in Slack and purge the public channel of the sensitive contract notes using the Slack admin API. 3. Long-term remediation. Refactor the Slack topic instructions to include channel filtering. The agent must verify the channel_type equals private before it is permitted to retrieve or summarize restricted Salesforce records. 4. Governance fix. Implement Salesforce to Slack permission sets. Ensure the Agentforce integration user in Salesforce has the same object-level security (OLS) as the human user in Slack to prevent unauthorized data exposure. Pro tip: Slack is public by default. When orchestrating Agentforce in Slack, you must treat every channel as a potential data leak. Always use channel metadata in your prompt templates to restrict AI responses based on the sensitivity of the Slack environment.
Production Incident 83. Tableau Pulse semantic mismatches occurred when querying data cloud insights via Agentforce, resulting in the AI reporting a record profit, while the actual Tableau dashboard showed a loss. This resulted in a boardroom crisis, where the CFO's trust in AI reporting was completely destroyed. How do you align the semantic layer?
Answer: This is a cross-platform semantic failure. I would immediately perform a semantic layer audit to compare the Tableau Pulse metric definition against the Data Cloud Calculated Insight (SQL). I would then find that the Tableau dashboard was using net revenue, while the Agentforce metric action was pulling gross revenue due to a mapping mismatch in the Tableau Pulse connector. To resolve this, I would unify both definitions into a single Data Cloud Calculated Insight and have Tableau Pulse subscribe to that DMO as its only source of truth. Finally, I would implement AI to Tableau traceability, where the agent must include a deep link to the actual Tableau dashboard in its response, allowing the CFO to verify the source of truth instantly. Pro tip: AI does not understand accounting nuance unless you define it. Always use Data Cloud Calculated Insights as the one source of truth for both Tableau and Agentforce. If you define the same metric in two different places, your AI will eventually provide a boardroom-ending contradiction.
The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
Production Incident 84. A platform event bus failure caused Agentforce to lose track of 5,000 asynchronous actions, resulting in customers being double billed because the success signal never reached the AI agent. How do you recover the asynchronous state?
Answer: This is an asynchronous state failure. I would handle the recovery through these steps. 1. Root cause. The platform event volume exceeded the org's daily event limit, causing the event bus to drop the 5,000 billing success notifications while the Agentforce agent was waiting for a callback. 2. Immediate containment. Use the Event Monitoring API to identify every billing_request that lacks a corresponding success_event and put those transactions into a manual audit queue. 3. Long-term remediation. Implement high-volume platform events with event replay. I would refactor the Agentforce billing topic to use the replay ID to poll the event bus for missed messages after a 60-second timeout. 4. Governance fix. Increase the org's platform event capacity and implement idempotent billing actions to ensure that even if the AI receives 2 success signals, the customer is only billed once. Pro tip. Platform events are not guaranteed unless you use replay IDs. For mission-critical AI orchestration like billing, always architect a fallback polling mechanism that allows Agentforce to verify the record status if the event bus fails to deliver the callback.
Production Incident 85. Cascading failure, a MuleSoft API gateway saturation, caused by an Agentforce reasoning loop, triggered a total blackout of all external enterprise services. The AI's recursive requests for account history overwhelmed the gateway, causing a denial of service DAOs that shut down the corporate website and the mobile banking app. How do you recover?
Answer: this is an AI-induced DAOs cascading failure. I would lead the following high-stakes recovery. 1. Root cause. An Agentforce topic instruction was too vague, causing the agent to retry the same MuleSoft call 500 times in 10 seconds when it received a 404 response. 2. Immediate containment. Immediately blackhole the Agentforce integration user's IP address at the MuleSoft load balancer to restore traffic to the website and mobile app. 3. Long-term remediation. Implement strict rate limiting and spike arrest policies in MuleSoft specifically for the Salesforce AI principle. I would then refactor the Agentforce action to include a hard retry limit of 3. 4. Observability fix. Set up a MuleSoft endpoint monitoring alert that triggers a kill switch on the Salesforce Agentforce topic if it detects a specific API call frequency anomaly from the AI. Pro tip. An autonomous agent can DDoS your own enterprise in seconds. Always implement spike arrest at the API gateway level to ensure your AI agents do not kill your production website while they are trying to help a single customer.
Production Incident 86. A CRM to ERP synchronization loop was triggered when an Agentforce agent updated a Salesforce order status, which triggered a MuleSoft sync to the ERP, which then sent a status update back to Salesforce, re-triggering the Agentforce agent. This resulted in 40,000 status emails sent to customers in 1 hour. How do you break the loop?
Answer: this is a cross-platform recursion failure. I would break the loop using these steps. 1. Root cause. Neither system was checking for the source of change, causing both systems to believe the other system's update was a new request that required a response. 2. Immediate containment. Deactivate the MuleSoft outbound sync flow and pause the Agentforce order topic while the duplicate emails are addressed by the marketing team. 3. Long-term remediation. Implement a source header in the sync payload. If the update originated from Agentforce, the ERP must update the record without sending a callback notification to Salesforce. 4. Governance fix. Add a recursion guard field in Salesforce, for example, last underscore updated underscore by underscore AI underscore underscore C. Agentforce sets this to true, and the sync flow only executes if the field is false. Pro tip: AI recursion is not just a Salesforce problem, it is a network problem. Always tag your AI-generated updates with a source metadata flag to ensure your external integrations know to ignore and commit rather than acknowledge and trigger.
Production Incident 87. Hyperforce failover inconsistencies resulted in Agentforce losing its secure tunnel to an AWS-hosted BYOL endpoint during a regional transition. The AI, unable to reach its logic engine, began providing default error responses to 50,000 customers, resulting in a 40% spike in support ticket volume. How do you restore the tunnel?
Answer: this is a Hyperforce to AWS resiliency failure. I would restore the connectivity as follows. 1. Root cause. The Hyperforce regional failover changed the inbound IP range for the Salesforce org, and the AWS security group firewall was not updated to allow the new IP range to reach the BYOL endpoint. 2. Immediate containment. Temporarily open the AWS security group to all Salesforce Hyperforce IP ranges and notify the AWS security team to update the allow list permanently. 3. Long-term remediation. Transition from IP-based allow listing to Salesforce Private Connect with AWS Private Link. This creates a dedicated permanent VPC to VPC connection that is unaffected by regional IP changes. 4. Governance fix. Implement a resiliency test in your CI and CD pipeline. Every quarter, perform a simulated failover to verify that Agentforce can still reach its external models from all Hyperforce regions. Pro tip: Hyperforce is mobile. Your org can move between regions. Never rely on static IP filters for your BYOM grounding. Always use Private Connect to ensure your AI's brain is always connected, regardless of which Hyperforce pod it is running on.
Production Incident 88. Real-time MuleSoft orchestration deadlocks occurred when 500 Agentforce agents simultaneously called a composite API to update multiple Salesforce records. The resulting database lock contention froze the entire org for 10 minutes. How do you resolve the deadlock?
Answer: this is a resource locking failure. I would resolve the deadlock through these steps. 1. Root cause. The MuleSoft composite API was attempting to update the parent account and all child contacts in a single transaction, causing a massive lock weight on the parent record. 2. Immediate containment. Immediately kill the MuleSoft worker threads and restart the API gateway to clear the pending database locks in the Salesforce org. 3. Long-term remediation. Refactor the Agentforce action to use asynchronous record updates. Instead of a composite API, have the agent publish a platform event that is processed by a flow triggered by event in smaller, non-blocking batches. 4. Governance fix. Implement lock-aware orchestration. Build a check before lock logic in MuleSoft that verifies record availability before attempting a mass update, returning a retry later to the AI agent if the record is locked. Pro tip: AI is a concurrent force. It will attempt to update 1,000 records at once. Never use synchronous composite APIs for mass AI updates. Always use asynchronous platform events to decouple the AI's request from the Salesforce database commit.
Production Incident 89. Third-party SaaS grounding corruption occurred when an external service integrating a legacy ticketing tool began sending malformed metadata to Agentforce. The AI, confused by the data, began deleting customer loyalty points to pay for support tickets. How do you fix the corrupted grounding?
Answer: this is an external service semantic failure. I would fix the grounding through these steps. 1. Root cause. The legacy SaaS tool renamed its amount_due field to balance, which Agentforce semantically misinterpreted as the customer's loyalty_balance_DMO due to a loose action mapping in Salesforce. 2. Immediate containment. Immediately disable the external service in Salesforce and pause any Agentforce topic that has destructive permissions on the loyalty object. 3. Long-term remediation. Implement strict schema validation in the external service definition. I would use an open API Swagger file with required field labels to ensure the agent only acts on verified, strictly mapped data. 4. Governance fix. Refactor the agent's action to be read only for external SaaS data. If the AI wants to pay for something, it must route to a human approval flow rather than acting autonomously on malformed metadata. Pro tip: external services are low code, but they are high risk. If your third-party SaaS tool changes its JSON schema, your AI could start making logical leaps that cost you thousands. Always use strict open API contracts to gate your AI's external actions.
Production Incident 90. Cascading failure, a multi-org data cloud consolidation conflict across global business units, resulted in identity collisions, where a CEO from the UK was merged with a standard customer from the US. Agentforce began sending restricted financial insights to the US customer, triggering a Securities and Exchange Commission (SEC) investigation into the firm's data privacy controls. How do you recover?
Answer: this is a multi-org governance cascading failure. I would lead the following high-stakes recovery. 1. Root cause. The global identity resolution rule set lacked a tenant_ID filter, causing the system to merge two different individuals who shared a common name and a generic company domain, for example, at gmail.com. 2. Immediate containment. Emergency shutdown of the global data cloud identity resolution job, and to authorize all Agentforce agents across all orgs until the profiles are split. 3. Long-term remediation. Implement org-based identity partitioning. I would refactor the match rules to require a source_org_ID match for any fuzzy name unification, ensuring that identities only merge across orgs if a global _UUID is present. 4. Executive fix. Build a compliance audit dashboard in Tableau Pulse. I would prove to the SEC that by implementing multi-org data spaces, the company has created an architectural firewall between its global customer identities. Pro tip: one data cloud to rule them all is a dangerous strategy for global enterprises. Always use data spaces and org ID filters in your identity resolution rules to ensure that a regional profile does not accidentally collide with a global VIP in a multi-org environment.
Category 6 Conclusion. The Orchestrator's Mandate.
Mastering multi-cloud orchestration is about moving from simple API callouts to resilient, stateful enterprise workflows. As we have seen, the complexity of managing SAP zero-copy, AWS Lambda cold starts, and recursive sync loops across global orgs requires a conductor who understands both the logic of the AI and the physics of the network. A principal architect ensures that Agentforce is never a silo, but an integrated force that respects API gateways, circuit breakers, and cross-platform semantic alignment.
The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the Masterclass.
Transition from Category 6 to Category 7.
But even the most perfectly orchestrated workflow will fail if it hits the hard walls of the Salesforce platform. In an autonomous enterprise, speed is the currency, but Salesforce governor limits are the law. When Agentforce reasoning engines saturate, data cloud vector queries spike, or Apex heap sizes explode, the system does not just slow down, it crashes. We must now move from the logic of orchestration to the performance and scalability of the platform. Let's explore the breaking points in Category 7.
Category 7. Enterprise Performance and Platform Limit Failures.
Scaling AI in a multi-tenant environment is a game of resource optimization. This category focuses on the performance collapse, those moments when vector database latency, async apex storms, and Hyperforce regional failovers turn your AI into a bottleneck. We test your ability to architect for high-volume inference while staying within the strict boundaries of the Salesforce trust model.
Category 7. Performance and Platform Limit Incidents 91 to 105.
Here are the 15 production incidents covering performance scaling and governor limit failures. Production Incident 91. Data Cloud Vector Database Query Latency Spikes During Peak Load. Production Incident 92. Einstein Trust Layer Gateway LLM Response Timeout Storms. Production Incident 93. Agentforce Concurrent Reasoning Engine Saturation. Production Incident 94. Apex heap size and CPU governor limit explosions via data graphs. Production Incident 95. Calculated insights query optimization failures causing processing delays. Production Incident 96. Platform event storm amplification caused by automated Agentforce triggers. Production Incident 97. Flow memory exhaustion during Agentforce triggered reasoning. Production Incident 98. Real-time personalization lag in Commerce Cloud via ingestion delays. Production Incident 99. Agentforce orchestrator bottlenecks in high concurrency environments. Production Incident 100. Data graph cache invalidation disasters causing fact staleness. Production Incident 101. Einstein Studio inference degradation impacting recommendation quality. Production Incident 102. Concurrent Agentforce actions creating record-locking deadlocks. Production Incident 103. High-volume BYOL API inference degradation and timeout chains. Production Incident 104. Salesforce Async Apex Queue backlog explosions from Agentforce callbacks. Production Incident 105. Hyperforce regional failover latency disrupting real-time AI responses. Total 15 incidents for performance and limits. Let's dive into Production Incident 91.
Production Incident 91. During a Black Friday flash sale, Data Cloud Vector Database query latency spiked from 200 milliseconds to 8.5 seconds, causing Agentforce to time out for 40,000 concurrent users. This resulted in a silent failure where the AI defaulted to I do not know for product availability queries, costing an estimated $620,000 in lost conversions. How do you optimize the search index?
Answer: this is a vector search saturation failure. I would handle the remediation through these steps. 1. Root cause. The search index was unoptimized and was performing a full scan on 2 million unstructured knowledge articles because the metadata filters were not properly indexed. 2. Immediate containment. Manually pause the vector search for non-critical topics and pivot the Agentforce agent to use keyword-based CRM search while the data cloud index is rebuilt. 3. Long-term remediation. Refactor the unstructured data pipeline to include hybrid search. By combining keyword and vector search with strict metadata filtering, for example, category equals holiday_promo, you reduce the search space and bring latency back under 300 milliseconds. 4. Performance fix. Implement vector query caching. For high-frequency queries, for example, what is your return policy? Cache the result in a data graph to prevent redundant hits to the vector DB. Pro tip: semantic search is compute expensive. Never perform a naked vector search across millions of records during peak load. Always use hard metadata filters in your search query to restrict the AI search to a specific subset of data, dramatically reducing latency.
Production Incident 92. A Einstein Trust Layer Gateway timeout storm occurred, where 80% of LLM requests failed to return a response within the 30-second platform window. This resulted in 120,000 incomplete conversation errors on the public website, triggering a wave of support tickets that crashed the Service Cloud console. How do you resolve the timeout storm?
Answer: this is a trust layer bottleneck failure. I would resolve the storm as follows. 1. Root cause. A sudden spike in prompt verbosity due to a complex new prompt template caused the LLM's token generation time to exceed the trust layer's 30-second gateway timeout. 2. Immediate containment. Instantly roll back the prompt builder template to the previous, leaner version to reduce the tokens per second load on the gateway. 3. Long-term remediation. Implement prompt engineering to reduce the grounding context. Instead of passing 10 data graphs, use calculated insights to pass a summarized context that requires fewer tokens for the LLM to process. 4. Architecture fix. Transition to a faster LLM, for example, GPT-4o Mini or Llama 3 for high-frequency service queries via the Einstein Model Playground to ensure response times stay under 10 seconds. Pro tip: the trust layer is a gateway, not a magic pipe. If your prompt is too long, the LLM takes longer to think, and the platform will kill the connection at 30 seconds. Always aim for token efficiency in your prompt builder templates to maximize concurrency.
Production Incident 93. Agentforce concurrent reasoning engine saturation occurred during a global marketing event where the org hit its concurrent agent sessions limit, Consequently, 15,000 VIP customers were met with a system busy message instead of their personalized AI concierge. How do you scale the reasoning capacity?
Answer: this is a platform multi-tenancy failure. I would first perform an audit of active topics to identify if any background agents like the sales prospecting agent are consuming sessions that should be prioritized for customer-facing service agents. I would then implement priority-based routing by creating a traffic controller flow that checks the customer's tier from data cloud. If the system is near its session limit, standard customers are routed to a static Einstein bot, while the Agentforce reasoning capacity is reserved for VIPs. Finally, I would work with the Salesforce account team to increase the concurrent session entitlement or move to an AI-specific Hyperforce pod that offers dedicated compute for high-volume enterprise reasoning. Pro tip: reasoning engines have soft and hard limits. Never allow your internal bots like sales agents to compete with your external bots' customer service on the same session pool. Always partition your reasoning capacity by priority to ensure your revenue-generating interactions never hit a system busy wall.
Production Incident 94. Cascading failure and Apex heap size and CPU governor limit explosion occurred when a prompt builder template attempted to process a 12 megabytes data graph payload for a single transaction. This crashed the order management trigger, resulting in a total blackout of order processing for 2 hours and an ERP reconciliation mismatch. How do you fix the heap explosion?
Answer: this is a payload scaling cascading failure. I would lead the following architectural fix. 1. Root cause. The data graph was configured to pull all historical line items over 5,000 records into a single Apex string variable, exceeding the 6 megabyte synchronous Apex heap limit. 2. Immediate containment. Disable the Agentforce order topic and initiate a metadata rollback of the data graph to include only the last 10 line items. 3. Long-term remediation. Implement data cloud summarization. Instead of passing raw line items to Apex, use a calculated insight to provide a financial summary DMO. This reduces the heap size from 12 megabytes to 2 kilobytes. 4. Governance fix. Implement heap limit monitoring in your Apex invocable actions. Use limits.get heap size at the start of the code if the payload is too large. The code must gracefully fail and route to a human rather than crashing the entire transaction. Pro tip: data graphs can be huge, but Apex heap is tiny. Never pass raw list data into a prompt template if the list could exceed 100 records. Always aggregate and summarize your data in Data Cloud before the Apex layer ever touches it.
Production Incident 95. Calculated Insights query optimization failures caused the daily risk refresh to take 14 hours instead of 40 minutes. Agentforce, operating on 24-hour-old risk data, approved high-risk transactions that should have been blocked, resulting in a $240,000 financial loss. How do you optimize the CI query?
Answer: this is a big data processing failure. I would optimize the CI as follows. 1. Root cause. The SQL used a non-index join between two massive DMOs engagement and individual, causing a Cartesian product that saturated the data cloud processing engine. 2. Immediate containment. Manually kill the hung CI process and update the Agentforce risk action to use a real-time flow check until the CI is fixed. 3. Long-term remediation. Refactor the CI SQL to use partition-aware filters. By adding aware event underscore time greater than last underscore 24 underscore hours clause, you reduce the data volume processed by 90% and restore the 40-minute refresh window. 4. Performance fix. Use materialized data graphs for frequent joins. Instead of doing a complex join in SQL every night, let Data Cloud maintain the relationship in a data graph which is optimized for high-speed retrieval. Pro tip: in Data Cloud, SQL is not free. A poorly written calculated insight will eventually hit a processing window timeout. Always filter your CI queries by time and use standard data models to ensure you are hitting indexed fields.
Production Incident 96. A platform event storm amplification occurred when an automated Agentforce status update re-triggered the same event bus 5,000 times in 1 minute. This exceeded the org's daily event limit and blocked all internal enterprise syncs, including emergency SOC alerts. How do you break the storm?
Answer: this is an event-driven recursion failure. I would break the storm through these steps. 1. Root cause. A circular dependency between an Agentforce action and a Salesforce flow caused each to publish a success event that the other was listening for, creating a 5,000 RPM loop. 2. Immediate containment. Use the Salesforce CLI to mass deactivate the triggering flow and purge the event bus to clear the pending 500,000 events. 3. Long-term remediation. Implement recursion headers in your platform events. Add a source_system__C field. If the event says Agentforce, the flow must commit the change without publishing a new event. 4. Governance fix. Implement event rate monitoring using Einstein observability. Build an automated circuit breaker that disables an Agentforce topic if it detects an event frequency spike of 1000% over the baseline. Pro tip: platform events are high speed. AI is higher speed. Always debounce your events. If Agentforce updates a record, wait 5 seconds before allowing any automated event to fire again to ensure you do not enter an unrecoverable event storm.
Production Incident 97. Flow memory exhaustion occurred during a complex Agentforce-triggered reasoning orchestration involving 20 nested loops. The flow crashed with an internal limit error, causing 5,000 abandoned orders in the mobile app. How do you refactor the orchestration?
Answer: this is a flow engine failure. I would refactor the orchestration as follows. 1. Root cause. The flow was attempting to hold 50,000 data cloud insight records in a single collection variable, exceeding the flow engine's memory limit for a single interview. 2. Immediate containment. Simplify the flow by removing the nested loops and pivoting to an apex invocable action that handles the data processing in a more memory-efficient way. 3. Long-term remediation. Implement data cloud data graphs with pre-filtering. Instead of pulling all 50,000 records into the flow, have the data graph only return the top 5 relevant records for the AI to reason over. 4. Performance fix. Use subflows and asynchronous paths. Break the 20-step process into 5 smaller flows that communicate via record updates, resetting the memory limit for each step of the reasoning. Pro tip: Flow is a low-code tool, not a data processing engine. If your Agentforce agent needs to reason over more than 50 records, Flow is the wrong tool. Move that logic into Apex or calculated insights to prevent memory exhaustion crashes.
Production Incident 98. Real-time personalization lag in B2C Commerce Cloud occurred because of a 4-minute delay in data cloud ingestion. Agentforce, unable to see the customer's current session behavior, offered winter coats to a customer who had just added swimwear to their cart, resulting in a 40% drop in add-to-cart conversion. How do you resolve the lag?
Answer: this is a last-mile ingestion failure. I would resolve the lag through these steps. 1. Root cause. The Web SDK ingestion was being batched every 5 minutes by a legacy CDN setting, preventing data cloud from seeing the session in real time. 2. Immediate containment. Update the Agentforce Commerce topic to prioritize in session context passed directly from the browser via the prompt payload over the data cloud DMO. 3. Long-term remediation. Transition the web engagement stream to streaming ingestion with a zero buffer configuration. I would then update the data graph to have a real-time triggered refresh. 4. Performance fix. Use Commerce Cloud Einstein for the immediate recommendation and use Agentforce plus Data Cloud for the Deep Context Loyalty or LTV, ensuring the customer sees swimwear in sub-seconds. Pro tip: personalization has 2 speeds, session speed and identity speed. For session speed, what I just clicked, always pass the context directly in the prompt. For identity speed, who I am, use Data Cloud. Do not mix the two.
The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
Production Incident 99. Agentforce orchestrator bottlenecks occurred in a high concurrency environment where the orchestrator service struggled to manage 50,000 simultaneous stateful conversations. This resulted in the AI mixing up customer identities, providing bank account balances to the wrong users. How do you resolve the bottleneck?
Answer: this is a stateful session failure and a catastrophic security breach. I would immediately shut down the Agentforce orchestrator and revoke all active AI sessions globally. For root cause analysis, I would investigate the session ID mapping in the orchestrator. I would find that under high concurrency, the shared memory was incorrectly recycling context pointers between different users. To resolve this, I would implement stateless orchestration. Instead of the orchestrator remembering the user, I would require every incoming request to include a verified JWT token containing the unified individual ID. Finally, I would move the Agentforce deployment to a dedicated performance tier in Hyperforce that provides isolated reasoning instances for high-volume banking apps. Pro tip: state is dangerous at scale. For high concurrency enterprise apps, always move your session context into the payload JWT or claims rather than relying on the AI orchestrator's internal memory, ensuring zero risk of identity bleed during peak load.
Production Incident 100. A data graph cache invalidation disaster occurred where 500,000 customers were shown expired pricing because the data cloud cache failed to flush after a price book update. Agentforce, grounded in the stale cache, issued 50,000 incorrect quotes in 1 hour. How do you fix the cache?
Answer: this is a cache consistency failure. I would resolve the staleness as follows. 1. Root cause. The data graph was configured with a fixed 2-hour TTL time to live and did not have an active invalidation trigger for the price book DMO. 2. Immediate containment. Manually trigger a global cache flush via the Data Cloud API and disable the Agentforce pricing topic for 15 minutes to allow the graphs to rehydrate. 3. Long-term remediation. Implement event-driven cache invalidation. Configure a data action that sends a clear cache signal to the data graph engine the moment any record in the price_book__DLM is updated. 4. Governance fix. Update the prompt template to include a price_timestamp check. If the price in the data graph is older than the current active price book version, the agent must refuse to quote. Pro tip: caching makes AI fast, but staleness makes AI dangerous. For volatile data like price or inventory, never use fixed TTL caching. Always use active invalidation triggered by the source system's update events.
Production Incident 101. Einstein Studio inference degradation occurred where a custom next best offer model began returning 0.01 confidence scores for all products, impacting Agentforce recommendation quality for 2 days. This resulted in a total collapse of cross-sell revenue. How do you recover the inference quality?
Answer: this is a model drift failure. I would recover the model through these steps. 1. Root cause. The training data used in Einstein Studio was harmonized differently than the inference data coming from the live Agentforce agent, causing a semantic mismatch in the model's logic. 2. Immediate containment. Pivot Agentforce to use a heuristic-based recommendation, for example, popular products, while the Einstein Studio model is realigned. 3. Long-term remediation. Implement feature store alignment. Ensure that both the training pipeline and the inference data graph use the exact same harmonized DMOs and calculated insights to prevent semantic drift. 4. Monitoring fix. Build a model performance dashboard in Data Cloud. If the mean confidence score drops below 0.6, an automated alert is fired and the Agentforce agent automatically switches to a safe fallback topic. Pro tip: predictive AI is sensitive to schema shift. If you change a DMO mapping in Data Cloud, your Einstein Studio model is now obsolete. Always revalidate your models after any change to your harmonized data layer.
Production Incident 102. Concurrent Agentforce actions created record-locking deadlocks on the account object during a mass account update campaign. The AI agents were attempting to update the same parent account simultaneously, freezing the org for 30 minutes. How do you resolve the deadlock?
Answer: this is a database contention failure. I would resolve the deadlock as follows. 1. Root cause. Agentforce was configured to perform synchronous Apex updates on the parent account for every child lead it processed, exceeding the lock wait limit of 10 seconds. 2. Immediate containment. Immediately aborted the Agentforce prospecting topic and used the Apex Flex queue to clear the blocked transaction threads. 3. Long-term remediation. Refactor the Agentforce action to be asynchronous. The agent publishes a platform event, which is then processed by a flow that batches the account updates into a single transaction every 2 minutes. 4. Architecture fix. Implement lock-aware Apex. Modify the invocable action to use the for-update clause with a limit 1 and a try-catch block. If the record is locked, the agent retries in 30 seconds. Pro tip: AI does not understand concurrency. It will try to hit the same record 100 times in a second. Always use asynchronous batching via platform events for AI-driven mass record updates to prevent record-locking disasters.
Production Incident 103. High-volume BYOM API inference degradation occurred where an external Azure OpenAI endpoint began returning 500 internal server errors under Agentforce load. This caused a timeout chain that crashed the Salesforce to Azure VPN. How do you fix the inference chain?
Answer: this is a distributed system failure. I would fix the chain through these steps. 1. Root cause. The external Azure endpoint was hit with 10,000 requests per minute from Agentforce, exceeding its token rate limit and causing it to drop connections, which then saturated the Salesforce VPN buffer. 2. Immediate containment. Enable the circuit breaker in the Salesforce external service configuration to immediately stop all requests to the Azure BYOM endpoint until the rate limit is reset. 3. Long-term remediation. Implement rate limiting at the Salesforce layer. Use an Apex invocable action to manage the Azure callouts, ensuring the agent never exceeds 100 requests per second. 4. Resiliency fix. Implement model failover. If the Azure BYOM endpoint returns a 500 or a 429 error, the Agentforce agent must automatically switch to the internal Einstein model for basic service continuity. Pro tip: bring your own model. BYOM makes you a service provider. If your external LLM is slow, your Salesforce org will feel broken. Always implement circuit breakers and model failovers to ensure your AI is not a single point of failure.
Production Incident 104. Cascading failure, a Salesforce Async Apex queue backlog explosion occurred when 200,000 Agentforce callback events arrived simultaneously. This caused a 3-hour delay for all scheduled jobs, resulting in 50,000 missing invoices and a board-level investigation into platform operational risk. How do you recover the queue?
Answer: this is an async resource exhaustion cascading failure. I would lead the following high-stakes recovery. 1. Root cause. Every Agentforce asynchronous action was generating a new queuable job, overwhelming the org's concurrent async execution limit and causing a total queue backup. 2. Immediate containment. Use the Apex Flex queue to reprioritize the invoice job to the front of the queue and abort all non-critical Agentforce activity log jobs to clear capacity. 3. Long-term remediation. Implement queuable batching. Refactor the Agentforce callback logic to use a staging object. A single scheduled batch job then processes 1,000 callbacks at once every 10 minutes, consuming one job instead of 1,000. 4. Governance fix. Implement async governance. Build a monitor that tracks async queue depth. If the backlog exceeds 5,000 jobs, Agentforce must automatically switch to a synchronous-only mode for all low-priority actions. Pro tip: this is the silent killer of Salesforce AI. High-volume AI will eat your async capacity. Always batch your AI callbacks into a staging object to protect your mission-critical batch jobs, like invoicing from being starved by AI activity.
Production Incident 105. Hyperforce regional failover latency disrupted real-time Agentforce responses for 100,000 users during a scheduled maintenance window. The 20-second delay in cross-region data cloud sync caused Agentforce to ground in empty profiles, resulting in "I do not know who you are" responses to VIPs. How do you architect for failover?
Answer: this is a cloud infrastructure failure. I would architect for failover as follows. 1. Root cause. During the Hyperforce failover, the data cloud to Agentforce metadata bridge took 20 seconds to repoint to the new region, causing a temporary data blackout for the AI reasoning engine. 2. Immediate containment. Update the Agentforce topic to use core CRM grounding as a primary fallback. If the data cloud profile is empty, the agent must query the sales cloud contact record directly to identify the user. 3. Long-term remediation. Implement multi-region data cloud availability. While expensive for Tier 0 banking apps, we architect 2 data cloud data spaces in 2 different regions with bi-directional sync to ensure 0-millisecond failover for AI grounding. 4. Governance fix. Build a resiliency dashboard for the CIO. I would prove that by having a local cache in the Agentforce session, the AI can maintain persona continuity even during a total regional data cloud disconnect. Pro tip: cloud does not mean always on. During a Hyperforce regional failover, your metadata moves faster than your data. Always architect your Agentforce agents to be dual, grounded in both data cloud and core CRM, to ensure they never forget your customers during a cloud migration.
Category 7 Conclusion. Respecting the platform physics.
Mastering enterprise performance is about understanding that Salesforce governor limits are not obstacles, but the physical laws of a multi-tenant universe. As we have seen, high-volume AI can easily crash an async queue, explode an Apex heap, or saturate a global reasoning engine. A principal architect ensures that Agentforce remains performant by summarizing data in data cloud before it hits Apex, batching callbacks into staging objects, and architecting for fail-soft resiliency during regional Hyperforce transitions.
The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the Masterclass.
Transition from Category 7 to Category 8.
But performance is meaningless if the AI is failing with speed, because it cannot retrieve the right facts. While the first 7 categories focused on structured data rows and columns, 80% of enterprise knowledge lives in unstructured formats: PDF, emails, and knowledge articles. The bridge between these documents and Agentforce is the unstructured data pipeline and vector search. When the retrieval layer fails, whether through poor chunking or stale embedding, the AI enters a hallucination spiral. We must now explore the retrieval augmented generation RAG layer in Category 8.
Category 8. RAG, Vector Search, and Data Cloud Unstructured Pipeline Failures.
Retrieval augmented generation RAG is what prevents AI from guessing. This category focuses on the retrieval collapse, those moments when PDF chunking cuts a contract clause in half, vector indexes become stale, and semantic search retrieves irrelevant documents. We test your ability to architect a search index that is factually accurate, semantically relevant, and operationally reliable.
Category 8. RAG and Vector Search Incidents 106 to 120.
Here are the 15 production incidents covering RAG and unstructured pipeline failures. Production Incident 106. Incorrect PDF chunking strategies causing context loss in Agentforce. Production Incident 107. Contract clause context loss due to poor vector search indexing. Production Incident 108. Hybrid search mismatches between CRM data and knowledge bases. Production Incident 109. Semantic retrieval irrelevance due to missing metadata filtering. Production Incident 110. Stale embeddings caused by failed unstructured pipeline refresh cycles. Production Incident 111. Delayed synchronization between knowledge updates and search indexes. Production Incident 112. Poor metadata mapping in data cloud causing grounding failures. Production Incident 113. Embedding dimensional mismatch when using BYOL embedding models. Production Incident 114. Retrieval ranking corruption prioritizing outdated SharePoint documents. Production Incident 115. Broken semantic similarity thresholds resulting in false positive answers. Production Incident 116. Agentforce hallucinations caused strictly by data cloud retrieval gaps. Production Incident 117. Duplicate vector indexing, inflating data cloud storage and compute credits. Production Incident 118. Cross-document context contamination in complex RAG templates. Production Incident 119. Incorrect top K retrieval configuration limiting reasoning context. Production Incident 120. Data cloud search index latency under high concurrent Agentforce load. Total 15 incidents for RAG and vector search. Let's dive into Production Incident 106.
Production Incident 106. An incorrect PDF chunking strategy in the data cloud unstructured pipeline resulted in critical liability clauses being cut in half across different vector chunks. Agentforce, only retrieving the first half of the clause, informed a customer they were eligible for a full refund that was actually legally restricted, leading to a $140,000 legal dispute. How do you fix the chunking?
Answer: this is a semantic segmentation failure. I would handle the remediation through these steps. 1. Root cause. The pipeline used a fixed-size chunking strategy, for example, 500 characters without overlapping or semantic awareness, causing logical sentences to be truncated at the character limit. 2. Immediate containment. Pause the Agentforce legal inquiry topic and implement a human-in-the-loop flag for any query involving refund eligibility or liability until the index is reprocessed. 3. Long-term remediation. Transition the unstructured pipeline to recursive character chunking or markdown, aware chunking with a 20% overlap, for example, 512 tokens with 100 tokens of context overlap. This ensures the context of the previous chunk is preserved in the next. 4. Governance fix. Implement section-based metadata. Tag each chunk with the header or section it originated from, allowing Agentforce to verify it has the complete clause before providing a legal summary. Pro tip: fixed chunking is the enemy of accuracy. Always use overlapping chunks 10 to 20% to ensure that the semantic meaning of a sentence is not lost at the border of a vector. For legal documents, semantic chunking based on headers is a mandatory safety requirement.
Production Incident 107. Poor vector search indexing caused Agentforce to fail the retrieval of specific exclusion clauses during an insurance claim review. The AI incorrectly approved 400 claims for water damage that were explicitly excluded in the master policy PDFs, resulting in a $2.4 million financial loss. How do you fix the indexing?
Answer: this is a retrieval recall failure. I would resolve the indexing gap as follows. 1. Root cause. The vector search index was configured with a low dimensionality model that failed to capture the semantic nuance between flood covered and seepage excluded. 2. Immediate containment. Immediately disable the autonomous claim approval action and revert to draft mode, where a human adjuster must verify every AI-suggested approval. 3. Long-term remediation. Re-index the policy documents using a high-dimensional embedding model, for example, text embedding 3 large in Einstein Studio. I would then implement hybrid search to ensure that exact keywords like seepage are prioritized over fuzzy semantic matches. 4. Monitoring fix. Build a retrieval accuracy test suite. I would create a gold dataset of 50 common exclusion queries and verify that the vector search retrieves the correct document chunk with greater than 95% confidence. Pro tip: vector search is vibe search. It is not exact search. For insurance or legal work, never rely on vector alone. Always use hybrid search vector plus keyword to ensure that specific legal buzzwords are caught by the keyword engine, even if the vector engine misses the nuance.
Production Incident 108. A hybrid search mismatch between structured CRM data showing a customer's platinum status and unstructured knowledge bases showing standard support hours caused Agentforce to provide incorrect support expectations to 2,000 VIPs. This resulted in a massive spike in escalation tickets. How do you align the structured and unstructured retrieval?
Answer: this is a contextual collision failure. I would immediately refactor the prompt builder template to enforce a logic hierarchy. The template must be configured to override any facts found in the unstructured knowledge base with structured CRM DMO data. For example, if individual_tier equals platinum, ignore standard support hours in the PDF. I would then implement metadata filtering in the vector search query, ensuring that the AI only retrieves knowledge articles that are tagged with the customer's specific service_level_agreement attribute. Finally, I would run a knowledge audit to identify and update any articles that contain hard-coded service levels that contradict the dynamic CRM data. Pro tip: AI is a synthesizer. If you give it 2 conflicting facts, it will average them. You must use prompt grounding to tell the agent which source is the master. Structured data CRM should always override unstructured data PDFs for specific customer entitlements.
Production Incident 109. Semantic retrieval irrelevance occurred when Agentforce retrieved a 5-year-old product manual for a query about a 2026 model, simply because the meaning of the text was similar. The customer followed the old instructions and damaged their $5,000 equipment. How do you enforce metadata filtering on the vector database?
Answer: this is a temporal retrieval failure. I would fix the filtering as follows. 1. Root cause. The vector search query lacked a metadata filter on the product_year or status fields, causing the engine to return the most similar text regardless of its validity. 2. Immediate containment. Update the Agentforce topic to include a mandatory source date check. If the retrieved document is older than 2025, the agent must ask the user to confirm their model year. 3. Long-term remediation. Implement hard metadata filtering in the Data Cloud Search Index. I would update the prompt builder query to explicitly include where status equals active and product_version equals 2026. 4. Governance fix. Configure the unstructured pipeline to automatically de-index or deprioritize any document marked as archived in Salesforce Knowledge, ensuring they never enter the AI's context window. Pro tip: similarity does not equal correctness. In a vector DB, a 2010 manual and a 2026 manual are semantically identical. You must use metadata filtering on a version or date field to gate what the AI is allowed to see.
Production Incident 110. A failed unstructured pipeline refresh went undetected for 10 days, leaving the Agentforce agent with stale embeddings that did not include a critical product recall notice. The AI continued to recommend the faulty product to 8,000 customers, creating a massive safety liability. How do you recover?
Answer: this is a vector staleness failure. I would lead the following recovery. 1. Root cause. The vector search index refresh job hung due to a malformed PDF file in the ingestion bucket, causing all subsequent document updates to be blocked. 2. Immediate containment. Manually quarantine the malformed PDF and trigger an emergency full re-index of the recall notice folder. Update the Agentforce topic to manually hard code the recall warning as a system message until the index is live. 3. Long-term remediation. Implement incremental indexing with failure alerts. I would set up a PagerDuty alert that triggers if the unstructured pipeline hasn't successfully processed a new document in over 4 hours. 4. Governance fix. Build a search index health dashboard in Tableau that tracks document count in CRM versus document count in vector index. If the delta is greater than 0, the system is officially stale. Pro tip: vector indexes are not live. There is a delay between saving a document and AI knowing the document. Always architect a high-priority alert path that bypasses RAG for critical safety or recall information.
Production Incident 111. A delayed synchronization between Salesforce knowledge updates and data cloud search indexes caused Agentforce to provide old pricing to customers for 6 hours after a price hike. This resulted in $85,000 in price matched losses as the company had to honor the AI's incorrect quotes. How do you fix the sync delay?
Answer: this is a sync latency failure. I would resolve the delay through these steps. 1. Root cause. The knowledge to data cloud connector was set to a standard batch frequency of 12 hours rather than a triggered refresh. 2. Immediate containment. Flush the data cloud search index cache and manually trigger the ingestion API for the knowledge object to force an immediate update. 3. Long-term remediation. Transition the knowledge ingestion to a change data capture CDC stream. This ensures that every time a knowledge article is published, a signal is sent to data cloud to re-embed that specific article in seconds. 4. Governance fix. Implement price verification in the Agentforce action. The agent must perform a real-time lookup of the price _book__C record before confirming any quote, using RAG only for description text. Pro tip: never use RAG for volatile data like price or stock. RAG is for slow-moving knowledge. If the data changes more than once a week, it should be a structured CRM lookup, not a vector search retrieval.
Production Incident 112. Poor metadata mapping in the data cloud unstructured pipeline caused Agentforce to fail all industry-specific grounding requests. The AI could not find the healthcare compliance PDFs because the industry field in knowledge was not mapped to the vector search index. How do you fix the grounding failure?
Answer: this is a metadata mapping failure. I would fix the grounding through these steps. 1. Root cause. The unstructured data map was only capturing the body of the article, ignoring the category and industry fields, which made it impossible for the prompt builder to filter the search results. 2. Immediate containment. Update the prompt builder template to use a broad semantic search, removing the industry filter while the metadata is being remapped. 3. Long-term remediation. Refactor the unstructured pipeline to include all custom fields as searchable metadata. I would then re-index the entire knowledge base to ensure every chunk is tagged with its industry and compliance level. 4. Governance fix. Implement mandatory metadata on knowledge. Use a Salesforce validation rule to ensure no article can be published unless its AI grounding fields industry, version, and topic are populated. Pro tip: vector search without metadata is just a vibe check. To make it enterprise grade, you must map every relevant CRM field as a metadata attribute in your search index so your prompt templates can filter with precision.
Production Incident 113. An embedding dimensional mismatch occurred when an architect attempted to use a custom BYOM embedding model 1024 dimensions to search an index built with Einstein standard 1536 dimensions. All Agentforce queries returned 0 results. How do you fix the mismatch?
Answer: this is a mathematical alignment failure. I would resolve the mismatch as follows. 1. Root cause. You cannot compare vectors of different lengths. The search query and the search index must use the exact same embedding model to produce compatible vectors. 2. Immediate containment. Revert the Einstein Studio configuration to use the standard Einstein embedding model to restore immediate search functionality. 3. Long-term remediation. If the custom model is required, you must delete and rebuild the entire data cloud search index using the 1024-dimension model for both ingestion and retrieval. 4. Governance fix. Implement model versioning in your AI DevOps pipeline. Never change an embedding model in production without a full index rebuild scheduled in a maintenance window. Pro tip. Embedding models are the language of your vector DB. If your index speaks English 1536 dimensions and your query speaks French 1024 dimensions, they will never understand each other. Always align your models one-to-one.
The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the Masterclass.
Production Incident 114. Retrieval ranking corruption occurred where Agentforce began prioritizing 10-year-old outdated SharePoint documents over new Salesforce knowledge articles for a product install query. This resulted in customers following obsolete safety procedures, leading to a series of technical support escalations. How do you fix the ranking?
Answer. This is a recency bias failure in the retrieval engine. I would first implement recency boosting by adding a decay function or a metadata filter in the prompt builder that prioritizes documents with a last underscore modified underscore date in the last 12 months. I would then check the SharePoint connector settings in Data Cloud to ensure that archived folders are explicitly excluded from the ingestion stream. To resolve the immediate confusion, I would adjust the top K retrieval logic to only return the 3 most recent documents and update the agent's instructions to. If you see 2 conflicting procedures, always use the one from Salesforce knowledge over SharePoint. Finally, I would run a semantic audit to see if the old SharePoint docs are keyword stuffed, causing them to appear artificially relevant to the search engine. Pro tip: vector search does not know what new means. It only knows similar. You must use hard metadata filtering on the is_latest or modified_date fields to prevent your AI from digging up digital fossils and presenting them as current facts.
Production Incident 115. Broken semantic similarity thresholds resulted in Agentforce providing hardware troubleshooting answers to software queries because the meaning of the words was slightly similar. For example, driver as a tool versus driver as software. This led to 500 customers attempting to physically open their devices. How do you fix the thresholds?
Answer: this is a relevance precision failure. I would fix the threshold logic as follows. 1. Root cause. The similarity threshold in the vector search configuration was set too low, for example, 0.5, allowing low confidence matches to be treated as valid grounding data. 2. Immediate containment. Increase the minimum confidence score to 0.85 in the data cloud search index configuration to filter out loose semantic matches. 3. Long-term remediation. Implement category-aware retrieval. Add a product_type metadata tag to all chunks and update the prompt builder template to only search within the specific category identified by the user's intent. 4. Governance fix. Implement LLM as a judge. Before the final response is shown, have a smaller evaluation model check if the retrieved chunk actually matches the user intent. If it is a mismatch, the agent must say, "I do not know." Pro tip: 0.7 is usually the danger zone for similarity. Below 0.8, the AI starts making creative leaps that lead to physical or operational risk. Always set your thresholds high and use metadata filters to keep the search in its lane.
Production Incident 116. Agentforce hallucinations were found to be caused strictly by data cloud retrieval gaps, where the AI attempted to auto-complete a missing answer rather than admitting it didn't have the document. This resulted in 400 incorrect tax advice summaries in a financial services org. How do you close the retrieval gap?
Answer: this is a grounding constraint failure. I would close the gap through these steps. 1. Root cause. The prompt builder template was missing a negative constraint, for example, only answer using the provided text, giving the LLM creative liberty to use its general training data. 2. Immediate containment. Update the system instructions to: you are a closed book assistant. If the provided context does not contain the answer, you must say, "I do not have that information." 3. Long-term remediation. Identify the search gaps by analyzing the reasoning logs for queries that returned 0 results. I would then trigger an emergency knowledge creation workflow to fill those specific content holes. 4. Governance fix. Enable Einstein trust layer citation. If the agent cannot provide a direct link to a data cloud document for its answer, the response must be blocked from the user. Pro tip: hallucinations are often user experience failures. If you do not tell the AI it is okay to say "I do not know," it will try to be helpful by lying. Always use closed book prompting for regulated industries.
Production Incident 117. Duplicate vector indexing, caused by re-ingesting the same S3 bucket twice, resulted in a 2x inflation of data cloud storage and compute credits, burning $12,000 in unbudgeted costs. Agentforce also began retrieving the same fact twice, slowing down response times. How do you fix the index bloat?
Answer: this is a vector redundancy failure. I would fix the bloat through these steps. 1. Root cause. The S3 data stream lacked a unique file hash check, causing the unstructured pipeline to treat file_v1 and file_v1_copy as two distinct documents and creating duplicate embeddings. 2. Immediate containment. Immediately pause the S3 ingestion stream and use the data cloud data deletion tool to remove all vector chunks associated with the duplicate S3 bucket. 3. Long-term remediation. Implement content-based deduplication. Use a MD5 hash of the file content as the primary key for the DLO. This ensures that if the same content is uploaded twice, it only generates one set of vectors. 4. Governance fix. Implement index monitoring. Build a dashboard that tracks document count versus vector count. If the vector count is not a consistent multiple of the document count, trigger an index audit. Pro tip: vector storage is expensive. If you have 1 million documents and 5 million vectors, you are doing it right chunking. If you have 1 million documents and 10 million vectors, you probably have identity crisis in your ingestion pipeline.
Production Incident 118. Cross-document context contamination occurred in a complex RAG template where Agentforce mixed up product A features with product B prices because both chunks were retrieved in the same top K window. This led to thousands of incorrect price quotes. How do you isolate the context?
Answer: this is a retrieval contextualization failure. I would isolate the context through these steps. 1. Root cause. The top K retrieval was set to 10, which pulled in too many similar-sounding documents from different product categories into a single prompt context. 2. Immediate containment. Reduce the top K retrieval to 3 and update the prompt builder template to include delimiter grounding, for example, document 1, text -- document 2, text. 3. Long-term remediation. Implement strict topic filtering. Before the RAG search, have Agentforce identify the primary product the user is asking about and apply a hard metadata filter on that product ID in the vector DB. 4. Governance fix. Use summary-based RAG. Instead of passing 10 raw chunks, have a pre-processing LLM summarize the 10 chunks into a single unified fact sheet before the final reasoning step. Pro tip: more context is not always better. If you feed the AI 10 highly similar documents, it will get semantic indigestion. Keep your top K low 3 to 5, and use metadata to ensure those 3 to 5 are the absolute gold standard for that specific query.
Production Incident 119. An incorrect top K retrieval configuration limited the Agentforce context window so severely that the agent missed the termination clause located on page 50 of a contract. The AI informed the customer they could not cancel, resulting in a formal consumer rights complaint. How do you optimize the context window?
Answer: this is a retrieval recall failure. I would optimize the window as follows. 1. Root cause. The top K was set to 1 to save tokens, causing the agent to only see the first page of the contract where the termination clause was not present. 2. Immediate containment. Increase the top K to 10 for all legal and contract topics and implement long context LLMs, for example, Claude 3.5 Sonnet via Einstein Studio to handle the larger payload. 3. Long-term remediation. Implement map-reduce retrieval. Have the system search for termination across the entire document, summarize each relevant section, and then pass the summarized termination context to the final agent. 4. Governance fix. Build a document coverage validator. If a document is over 20 pages, Agentforce must use specialized search for specific legal keywords rather than a generic semantic retrieval. Pro tip: token cost is a bad reason to sacrifice accuracy. If you are reasoning over large documents, contracts, or manuals, you must use a high top K 10 to 20 and a large context window model to ensure the AI sees the needle in the haystack.
Production Incident 120. Cascading failure data cloud search index latency under high concurrent Agentforce load caused a 45-second delay in RAG responses. This triggered a retry storm from the mobile app, which saturated the Einstein trust layer and eventually crashed the MuleSoft API gateway, resulting in a total support blackout for 3 hours. How do you recover?
Answer: this is a retrieval to infrastructure cascading failure. I would lead the following high-stakes recovery. 1. Root cause. The vector search was performing an uncached query for every retry, overwhelming the data cloud compute workers and causing a distributed denial of service DDoS on the trust layer gateway. 2. Immediate containment. Immediately enable request deduplication at the MuleSoft gateway to drop the retry storm and black hole the RAG topic to allow the search index to cool down. 3. Long-term remediation. Implement query caching for the search index. I would store the results of common RAG queries in a Redis cache or a data graph to reduce the hit rate on the vector DB by 70%. 4. Executive fix. Build a system health dashboard. I would prove to leadership that by implementing exponential backoff in the mobile app and circuit breakers in the trust layer, the system can gracefully degrade rather than collapsing. Pro tip: search latency is the first domino in a platform crash. Always architect your mobile and web apps to wait for the response rather than retrying the prompt. A retry in an AI system is just a self-inflicted DDoS on your most expensive infrastructure.
Category 8 Conclusion. The accuracy of retrieval.
Mastering the unstructured data pipeline in RAG is about moving beyond keyword search and into factual precision. As we've seen, the risks of poor chunking, stale embeddings, and unmapped metadata are not just technical errors. They are the root causes of multi-million-dollar legal disputes and safety liabilities. A principal architect ensures that Agentforce is always grounded in a gold standard search index, utilizing hybrid search, semantic thresholds, and metadata filtering to ensure the AI speaks with the authority of the enterprise's true knowledge.
The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
Transition from Category 8 to Category 9.
But even with perfect data and factual accuracy, there are moments where an AI should not act alone. Whether it is an angry VIP customer or a high-stakes contract negotiation, the most successful AI architectures know exactly when to step back and bring in a human. This handoff, orchestrated via Omni-Channel, is where the technical engine meets human empathy. If this handoff is clunky, loses context, or saturates the routing queue, the entire AI strategy collapses at the last mile. We must now move from the retrieval of facts to the human in the loop and escalation architecture. Let's explore Category 9.
Category 9. Omni-Channel Human in the Loop HITL and Escalation Scenarios.
The transition from AI to human is the most sensitive moment in the customer journey. This category focuses on the handoff collapse, those moments when omni-channel routing saturates, conversation context is lost, and record-locking deadlocks occur between AI and human agents. We test your ability to architect a seamless, context-aware bridge that ensures the human agent is empowered, not overwhelmed, by the AI's escalation.
Category 9. Human in the Loop and Escalation Incidents, 121 to 130.
Here are the 10 production incidents covering omni-channel routing and human AI collaboration failures. Production Incident 121. Agentforce to omni-channel routing bottlenecks and queue saturation. Production Incident 122. Total loss of conversation context payload during Agentforce to human handoff. Production Incident 123. Service Cloud human agents rejecting or ignoring Einstein work summaries. Production Incident 124. Agentforce failing to recognize human emotional sentiment and delaying urgent case escalation. Production Incident 125. Record-locking collisions between autonomous Agentforce actions and human agent edits. Production Incident 126. Omni-channel SLA violations caused by Agentforce reasoning loops. Production Incident 127. Skills-based routing mismatch during Agentforce to service escalation. Production Incident 128. Data masking failures exposing unmasked PII to human agents during AI handoff. Production Incident 129. Supervisor dashboard blackout during mass AI to human escalation spikes. Production Incident 130. Cascading failure reasoning loop triggers mass escalation, crashing omni-channel. Total 10 incidents for human in the loop. Let's dive into Production Incident 121.
Production Incident 121. An omni-channel routing bottleneck occurred when Agentforce escalated 400 complex cases simultaneously to a specialized support tier. The routing engine saturated, causing a 45-minute ghost queue where customers were connected to offline agents. How do you resolve the routing bottleneck?
Answer: this is a routing capacity failure. I would resolve the bottleneck through these steps. 1. Root cause. The omni-channel limit for concurrent work items was hit because Agentforce was not checking agent availability before initiating the transfer to agent action. 2. Immediate containment. Update the Agentforce topic to include a presence check via Apex. If the specialized skill queue has 0 available agents, the AI must keep the customer engaged or offer a call back rather than escalating into a dead queue. 3. Long-term remediation. Implement overflow routing. Configure Omni-Channel to automatically route AI-escalated cases to a generalist queue with a high priority flag if the specialized queue wait time exceeds 2 minutes. 4. Performance fix. Use skills-based routing instead of queue-based to broaden the pool of available agents and increase the capacity wait for human agents to ensure they are not overwhelmed by mass AI transfers. Pro tip: Agentforce is infinite, but your human agents are finite. Never architect an unconditional escalation. Always have the AI check real-time agent capacity before telling a customer they are being transferred to a human.
Production Incident 122. A total loss of conversation context occurred during an Agentforce to human handoff for 200 VIP customers. The human agents received blank transcripts, forcing the VIPs to repeat their entire problem, resulting in a 4.0 drop in CSAT customer satisfaction and a public complaint from a top-tier client. How do you recover the context?
Answer: this is a context payload failure. I would handle the recovery through these steps. 1. Root cause. The conversation entry record in Data Cloud was not properly linked to the live chat transcript during the handoff because the session_ID was truncated by a custom LWC on the utility bar. 2. Immediate containment. Train agents to use the Data Cloud Customer 360 timeline to manually view the last 50 minutes of customer events while the Einstein work summary is being resynced. 3. Long-term remediation. Refactor the handoff logic to use Einstein work summaries generative. Instead of passing a raw transcript, the AI must generate a handoff JSON containing the intent, the facts gathered, and the current frustration level. 4. Governance fix. Implement handoff validation. If the context object is empty, Agentforce must retain the customer for an extra 10 seconds while it retries the context sharing apex call before completing the transfer. Pro tip: the handoff is where AI trust is won or lost. Always use Einstein work summaries as a redundant context layer. If the transcript fails to load, the human agent should still have a 3-sentence summary of the story, so far appearing on their console.
Production Incident 123. Service Cloud human agents are found to be rejecting or ignoring the Einstein work summaries generated after Agentforce handoffs because the summaries are too verbose and contain irrelevant data. This resulted in a 30% increase in average handle time (AHT) as agents spent more time reading than talking. How do you optimize the summaries?
Answer: this is a prompt optimization failure. I would immediately review the Einstein work summary prompt template and implement strict formatting. I would refactor the prompt to use bullet point summarization with a 150-word limit, explicitly excluding standard greetings and focusing only on unresolved actions. To restore agent trust, I would implement a feedback loop where agents can rate the summary. If a summary score drops below 3 stars, the architecture team receives an alert to refine the grounding data. Finally, I would ground the summary in actionable DMOs only, ensuring that the human agent sees exactly what the AI did and what it could not do as the very first line of the summary. Pro tip: agents do not want a novel, they want a briefing. Use Prompt Builder to enforce a TLDR too long, didn't read structure for every AI to human handoff. If a rep cannot understand the situation in 5 seconds, the summary has failed.
Production Incident 124. Agentforce failed to recognize high frustration and sarcasm in a customer's tone, continuing to provide upbeat AI responses while the customer threatened legal action. The delay in urgent case escalation resulted in a viral social media outrage and a PR crisis for the brand. How do you fix the sentiment-driven escalation?
Answer: this is a sentiment classification failure. I would resolve the escalation gap through these steps. 1. Root cause. The Einstein trust layer was masking certain angry keywords as toxicity, preventing the Agentforce reasoning engine from seeing the customer's true emotional state. 2. Immediate containment. Update the Agentforce topic to include emergency escalation keywords, for example, lawyer, court, attorney, that trigger an instant transfer regardless of the AI's sentiment score. 3. Long-term remediation. Implement streaming sentiment analysis in Data Cloud. I would use a streaming insight to monitor the conversation for a negative sentiment trend. If the sentiment score drops by 0.5 points over 3 messages, the agent is automatically escalated. 4. Governance fix. Implement supervisor silent monitoring. Build an alert in Omni-Channel supervisor that flags any AI-led conversation where sentiment equals critical, allowing a human supervisor to barge in manually. Pro tip: AI is notoriously bad at sarcasm. Never rely on general sentiment for high-stakes escalation. Always use a trigger keyword list as a safety net to ensure that customers who mention legal or social media are immediately pulled out of the AI loop and handed to a senior human agent.
Production Incident 125. A record-locking collision occurred when an autonomous Agentforce action attempted to update an opportunity stage at the exact same moment a human account executive was editing the amount. The AE's update was rejected, and the $500,000 deal data was lost. How do you resolve the concurrency conflict?
Answer: this is a database concurrency failure. I would resolve the locking through these steps. 1. Root cause. Agentforce and the human agent were hitting the same record ID in a synchronous window. Salesforce record locking prioritized the AI's Apex transaction, causing the AE's UI save to fail. 2. Immediate containment. Set the Agentforce topic to read only for any opportunity with an active owner currently logged into the system, until the concurrency logic is refactored. 3. Long-term remediation. Implement asynchronous AI updates. Instead of Agentforce updating the opportunity directly, it should write to a suggested _update ___C child record. The AE then receives a notification to accept or reject the AI's suggested stage change. 4. Governance fix. Implement optimistic locking. Add a system_mod stamp check in the Agentforce invocable action. If the record has been updated by a human in the last 60 seconds, the AI must back off and retry later. Pro tip: the AI versus human race condition is a common enterprise pain point. Always architect your Agentforce sales actions as suggestions using custom objects rather than hard writes to prevent the AI from fighting with your reps for control of the same record.
The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the Masterclass.
Production Incident 126. An Omni-Channel SLA violation occurred when an Agentforce agent entered a reasoning loop, holding the customer's routing session for 12 minutes without either resolving the issue or escalating it. The customer's total wait time exceeded the 5-minute SLA, resulting in a contractual penalty with a major client. How do you fix the reasoning timeout?
Answer: this is a reasoning duration failure. I would handle the remediation through these steps. 1. Root cause. The instructions for the agent were too complex, causing the LLM to recursively call multiple search actions in a loop while trying to be perfect, rather than escalating when it hit a roadblock. 2. Immediate containment. Implement a hard timer in the Agentforce inbound flow. If the conversation has not reached a resolution or escalation within 4 minutes, the flow must force an omni-channel transfer immediately. 3. Long-term remediation. Simplify the topic instructions to include threshold-based escalation. Tell the agent, if you cannot find the answer after 2 search attempts, you must offer to transfer to a human agent. 4. Governance fix. Build an AI hangtime monitor in Tableau. If an agent's average reasoning duration exceeds 2 minutes, it is automatically flagged for prompt pruning to reduce token loops. Pro tip: an AI that thinks too much is a liability. Always set an instruction level limit on how many actions the agent can take before it is forced to escalate. In high-stakes service, a fast "I do not know, let me get a human" is better than a slow, perfect answer.
Production Incident 127. A skills-based routing mismatch occurred when Agentforce escalated a technical deep dive query to a generalist queue because it failed to correctly identify the product's developer tier complexity. This resulted in a 45-minute resolution delay, as the case had to be manually rerouted twice. How do you optimize the handoff skill mapping?
Answer: this is a skill classification failure. I would resolve the mapping as follows. 1. Root cause. The Agentforce agent was passing a generic product_ID to the routing engine, but the omni-channel skill mapping required a complexity_score which the AI was not configured to calculate. 2. Immediate containment. Update the Agentforce handoff topic to ask one mandatory clarifying question, for example, are you looking for a PI help or UI help, before initiating the transfer. 3. Long-term remediation. Implement AI-driven skill tagging. Before escalating, the agent must call an Apex invocable action that maps the customer's topic to a specific Salesforce skill ID based on the conversation context. 4. Governance fix. Build a routing accuracy report. Compare the initial AI-suggested skill versus the final resolution skill. If the accuracy is below 80%, the topic instructions must be refined with more specific product keywords. Pro tip: do not just transfer, classify. An architect's job is to ensure Agentforce acts as the pre-triage engine. Use the AI to populate the skill requirement fields in Omni-Channel before the case hits the routing bus to ensure it lands with the right expert the first time.
Production Incident 128. A data masking failure occurred during a high-stakes Agentforce handoff, where unmasked PII, including a raw social security number, was visible in the conversation transcript provided to a human agent. This resulted in a major security compliance violation and a 48-hour shutdown of the AI service. How do you resecure the transcript?
Answer: this is a trust layer or handoff failure. I would resecure the context as follows. 1. Root cause. The Einstein trust layer was configured to mask PII for the LLM inference, but the save transcript to Salesforce action was pulling from a raw buffer that bypassed the masking engine. 2. Immediate containment. Immediately purge the affected transcript records using the Data Cloud Deletion API and suspend the service agent topic until the masking logic is verified. 3. Long-term remediation. Refactor the transcript storage to use deterministic masking at the inbound SDK layer. This ensures that PII is masked before it even reaches the Agentforce session. 4. Compliance fix. Implement trust layer audit logs. Build a monitor that flags any transcript where the PII detection score is high, but the masking flag is false, indicating a configuration bypass. Pro tip: masking for the AI is different than masking for the org. Always ensure your trust layer policies are applied to the conversation entry records that humans read. If you only mask the prompt, you are leaving your human agents exposed to raw, regulated data.
Production Incident 129. A supervisor dashboard blackout occurred during a mass AI to human escalation spike, where the omni-channel supervisor screen failed to update in real time. Human managers were flying blind as the queue surged from 50 to 800 pending cases in minutes. How do you restore visibility?
Answer: this is an observability under stress failure. I would restore visibility through these steps. 1. Root cause. The high frequency of AI to human events overwhelmed the push topic responsible for updating the supervisor UI, causing the real-time dashboard to lag by 15 minutes. 2. Immediate containment. Pivot the supervisors to a custom Tableau CRM dashboard that queries the pending service routing object directly via the API, bypassing the broken supervisor UI. 3. Long-term remediation. Implement escalation throttling. Configure Agentforce to stagger its escalations, for example, only 20 transfers per minute during a storm to allow the Omni-Channel UI to catch up with the event stream. 4. Governance fix. Build an emergency alert in Slack or email. If the pending case count in Omni-Channel spikes by more than 160 seconds, an automated system alert is sent directly to all service managers. Pro tip: real-time dashboards have limits. During a mass AI failure, your standard Salesforce dashboards will be the first thing to break. Always have a secondary monitoring path like Tableau or a custom API script ready for your supervisors to use during an AI crisis.
Production Incident 130. Cascading failure and Agentforce reasoning loop triggered 5,000 emergency escalations in 10 minutes, which crashed the Omni-Channel routing bus and subsequently saturated the company's phone system as customers pivoted to voice. This resulted in a total support blackout and an executive-level post-mortem. How do you recover?
Answer: this is an AI to infrastructure cascading failure. I would lead the following high-stakes recovery. 1. Root cause. A vague action instruction caused the AI to escalate whenever it received a wait signal from the database, creating a positive feedback loop of escalations that overwhelmed every support channel. 2. Immediate containment. Immediately shut down the Agentforce service topic and implement an emergency IVR message on the phone system to acknowledge the outage and divert traffic to a web form. 3. Long-term remediation. Implement a global circuit breaker in Omni-Channel. If the number of AI-initiated escalations exceeds 100 per minute, the system must open the circuit and force all subsequent customers to an asynchronous email path. 4. Executive fix. Build a resiliency dashboard for the CIO. I would prove that by implementing rate-limited escalations and cross-channel traffic controllers, the company can prevent a single AI error from bringing down the entire enterprise support infrastructure. Pro tip: this is the architect's nightmare. An AI failure can amplify it into a phone system failure in seconds. Always architect a circuit breaker at the omni-channel layer that can kill AI escalations automatically before they melt your human support infrastructure.
Category 9 Conclusion. Bridging the empathy gap.
Mastering human-in-the-loop HITL architecture is about recognizing that AI is an assistant, not a replacement for human judgment. As we have seen, the risks of lost context, routing bottlenecks, and sentiment blindness can destroy customer trust in seconds. A principal architect ensures that the handoff is stateful, context-rich, and capacity-aware, utilizing Einstein work summaries and real-time presence checks to ensure that the transition from AI to human is invisible to the customer and empowering for the agent.
The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The Elite Transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the Masterclass.
Transition from Category 9 to Category 10.
But even a perfectly orchestrated handoff will fail if the underlying platform rejects the transaction. In the Salesforce ecosystem, the laws of physics are the governor limits. No matter how intelligent Agentforce becomes, it is still bound by the 10-second invocable timeout, the 6 megabytes apex heap limit, and the strict hierarchy of object-level security. To build truly reference-grade AI, you must understand where the platform ends and the architecture begins. We must now explore the final technical frontier: Salesforce platform nuances and core boundaries. Let's dive into Category 10.
Category 10. Salesforce Platform Nuances and Core Boundaries.
The Salesforce platform is a multi-tenant environment with strict guardrails. This category focuses on the platform collapse, those moments when flow iterations exceed limits, data graphs explode apex heaps, and invocable actions hit the 10-second timeout wall. We test your ability to architect high-scale AI solutions that respect the native boundaries of the Salesforce ecosystem.
Category 10. Platform Nuances and Limit Incidents 131 to 140.
Here are the 10 production incidents covering core platform boundaries and governor limit failures. Production Incident 131. Flow execution limits exceeded via iterative Agentforce list processing. Production Incident 132. Apex heap size explosions when passing large data graphs to prompt templates. Production Incident 133. Invocable action timeout failures 10-second limit during external callouts. Production Incident 134. Copilot execution failures due to OLS or FLS mismatches on grounded data. Production Incident 135. CPU time limit violations caused by recursive Agentforce reasoning loops. Production Incident 136. Mixed DML errors triggered by Agentforce updating setup and non-setup objects. Production Incident 137. Shared resource exhaustion in Hyperforce pods during mass AI deployments. Production Incident 138. License type mismatches preventing Agentforce from accessing data cloud DMOs. Production Incident 139. Concurrent UI versus AI save conflicts triggering unable to lock row errors. Production Incident 140. Event bus daily limit exhaustion caused by AI human activity ping-pongs. Total 10 incidents for platform nuances. Let's dive into Production Incident 131.
Production Incident 131. During a mass reconciliation campaign, an Agentforce agent triggered a Salesforce flow to process a list of 2,000 line items. The flow crashed with a number of iterations exceeded error, resulting in 1,200 records remaining in an unprocessed state and causing a major financial audit gap. How do you refactor the iterative processing?
Answer: this is a flow engine boundary failure. I would handle the refactoring through these steps. 1. Root cause. The flow was using a loop element to process the 2,000 items. Salesforce flows have a limit of 2,000 executable elements per interview, which is easily hit when loops are used on large collections. 2. Immediate containment. Manually identify the unprocessed records using a report and use a data loader batch to finish the reconciliation while the flow is being refactored. 3. Long-term remediation. Transition the list processing from a flow to a batch Apex job. I would refactor the Agentforce action to submit the list to a custom staging object, which then triggers an asynchronous batch Apex to handle the 2,000 items in chunks of 200. 4. Governance fix. Implement collection truncation in the flow. If Agentforce passes more than 100 records, the flow should fault and route the task to an Apex invocable method designed for high-scale processing. Pro tip: flow is for logic, not mass data. If your Agentforce agent needs to process more than 50 records in a single loop, you have reached the boundary of low code. Always pivot to batch Apex or data cloud data actions for high-volume collection processing.
Production Incident 132. Cascading failure. An Apex heap size explosion occurred when a prompt builder template attempted to ingest a 12 megabytes data cloud data graph payload. The resulting system.limit exception crashed the invoice generation process, leading to 5,000 missing customer invoices and an $800,000 cash flow delay. How do you resolve the heap explosion?
Answer: this is a payload to platform cascading failure. I would lead the following recovery. 1. Root cause. The data graph was configured as an infinite depth graph, pulling in every historical transaction for a customer. When the resulting JSON was passed to the Apex invocable, it exceeded the 6 megabyte synchronous heap limit. 2. Immediate containment. Immediately unpublish the offending data graph and retrigger the invoice generation batch job without the AI-generated summary component to restore cash flow. 3. Long-term remediation. Implement graph pruning. I would update the data graph definition to include only the top 5 most recent records. I would also use calculated insights to provide a summarized DMO rather than passing raw JSON strings. 4. Governance fix. Implement heap-safe invocables. Add a check using limits.getHeapSize before processing the data graph. If the size exceeds 4 megabytes, the code must summarize the data locally or truncate the list to prevent a crash. Pro tip: data graphs are heavy and Apex is light. Never pass a raw data graph into a prompt template if you cannot guarantee the size. Use calculated insights to pre-aggregate your data in data cloud, so you only pass a tiny, high-value summary to the Apex layer.
Production Incident 133. An Agentforce agent attempting to verify a real-time shipping quote via an external REST API frequently hit the 10-second invocable timeout. The agent provided 4,000 "I cannot reach the carrier" errors to customers, leading to a 35% drop in checkout conversions. How do you handle the external latency?
Answer: this is a synchronous timeout failure. I would resolve the latency as follows. 1. Root cause. The external shipping carrier's API had an average response time of 12 seconds during peak hours, which exceeds the hard 10-second limit for synchronous Salesforce callouts. 2. Immediate containment. Update the Agentforce topic to include a fallback quote based on historical data cloud averages, ensuring the customer can still complete the purchase while the live API is slow. 3. Long-term remediation. Transition the orchestration to an asynchronous callback model. Agentforce triggers a quote request platform event and MuleSoft fetches the data. Once the data arrives, a Salesforce data action notifies the Agentforce session to update the UI. 4. Performance fix. Implement MuleSoft caching. Have MuleSoft cache shipping rates for 60 minutes for common routes, allowing the 10-second invocable action to hit the cache in sub-seconds. Pro tip: 10 seconds is an eternity in AI, but a blink of an eye for a legacy ERP. Never architect Agentforce to wait synchronously for external data. Always use asynchronous callbacks or MuleSoft caching to protect your AI from the latency of external systems.
Production Incident 134. A Copilot execution failure occurred where the Agentforce agent had the correct system permissions, but the specific sales rep executing the prompt lacked object-level security (OLS) for the grounded data cloud records. The AI provided empty or misleading answers to the rep. How do you resolve the permission mismatch?
Answer: this is a user contextual security failure. I would resolve the mismatch through these steps. 1. Root cause. Agentforce respects the user context. While the integration user could see the data, the human user did not have the data cloud data space user permission set, causing the prompt grounding to return null. 2. Immediate containment. Grant the data cloud permission set to the affected sales reps and manually refresh their Agentforce sessions to reestablish the security handshake. 3. Long-term remediation. Implement permission auditing. I would build a dashboard that cross-references Agentforce topic access with data cloud DMO permissions to identify any user who can talk to the agent but cannot see the data. 4. Governance fix. Use system context Apex where appropriate. If the data is restricted but necessary for the AI to function like a credit score, use a without sharing Apex invocable to fetch the facts securely without exposing the raw record to the rep. Pro tip: Agentforce is user-aware. It does not have God mode. Always ensure your data cloud and Salesforce core permissions are perfectly aligned. If the human cannot see the field, the AI cannot use it for grounding in that specific session.
Production Incident 135. Cascading failure, a CPU time limit violation caused by a recursive Agentforce reasoning loop crashed a mission-critical nightly billing batch. The crash resulted in 12,000 customers not being charged, leading to a regulatory reporting failure and a CFO-level inquiry. How do you recover the CPU capacity?
Answer: this is a resource contention cascading failure. I would lead the following high-stakes recovery. 1. Root cause. An always-on Agentforce agent was recursively querying a price book object that shared the same CPU thread as the billing batch, causing the batch job to time out after 10 seconds. 2. Immediate containment. Immediately kill the Agentforce service account's active sessions and abort the failed billing batch to clear the CPU locks in the Hyperforce pod. 3. Long-term remediation. Implement transaction isolation. I would move the billing batch to a scheduled window where the Agentforce agent is restricted to read-only access, preventing the AI from competing for write locks and CPU time. 4. Executive fix. Build an AI resource quota report. I would prove to leadership that by moving the billing logic into data cloud data actions which run off core, the core CRM CPU is protected from AI-driven saturation. Pro tip: CPU time is the most expensive resource in Salesforce. If your AI is thinking on the same CPU that is billing, you are risking an enterprise outage. Always move heavy logic to data cloud or MuleSoft to keep your core CRM CPU lean and available.
The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the Masterclass.
Production Incident 136. A mixed DML error was triggered when an Agentforce agent attempted to update a user record setup object and an opportunity record non-setup object in the same transaction. This crashed the sales pipeline for 400 reps. How do you resolve the mixed DML?
Answer: this is a transaction nuance failure. I would resolve the crash as follows. 1. Root cause. The Agentforce action was configured to update the sales rep's territory on the user record and the opportunity stage in a single invocable action, which Salesforce forbids in synchronous apex. 2. Immediate containment. Split the invocable action into 2 separate actions and update the topic instructions to ensure the agent calls them sequentially in 2 different reasoning steps. 3. Long-term remediation. Refactor the setup object update to be asynchronous. Use an @future method or a queuable job to handle the user record update, allowing the opportunity update to commit synchronously. 4. Governance fix. Implement DML guardrails. Build a developer standard that prohibits any Agentforce action from touching setup objects directly. All such updates must be routed through an async system orchestrator flow. Pro tip: mixed DML is a classic Salesforce gotcha. Agentforce does not know the difference between a user record and an account record. As the architect, you must sanitize your invocable actions to ensure setup and non-setup objects never meet in the same transaction.
Production Incident 137. Shared resource exhaustion in your Hyperforce pod occurred during a mass Agentforce deployment, causing all Apex web service calls to fail for 4 hours. Your org was soft-locked by Salesforce infrastructure as your AI traffic was perceived as a DDoS attack. How do you negotiate the restoration?
Answer: this is a platform multi-tenancy failure. I would immediately open a Severity 1 case with Salesforce support and provide the Agentforce reasoning logs to prove that the traffic was legitimate business automation, not a malicious attack. For immediate recovery, I would implement traffic throttling by disabling 50% of the non-essential AI topics to reduce the load on the Hyperforce pod. For long-term prevention, I would work with the Salesforce capacity planning team to move the org to a dedicated performance instance or implement Salesforce Private Connect to bypass the public API gateway. Finally, I would implement exponential backoff in my MuleSoft integrations to ensure that if the platform starts throttling, the AI cools down automatically rather than accelerating the crash. Pro tip: you are not alone on the server. If your AI agents generate too much noise, the Salesforce throttling engine will treat you like a hacker. Always architect your high-volume AI actions to be burst-aware and use Private Connect to give your enterprise AI its own dedicated fast lane.
Production Incident 138. A license type mismatch prevented Agentforce from accessing critical loyalty DMOs in Data Cloud for 5,000 customers. The agent, lacking the correct Data Cloud license context, provided "I cannot see your points" answers to VIPs, leading to a wave of churn. How do you fix the license gap?
Answer: this is a provisioning failure. I would fix the license gap as follows. 1. Root cause: the Agentforce service user was assigned a platform license which lacked the Data Cloud add-on permissions, whereas the Data Cloud DMOs required a full CRM license context to be queried via the AI engine. 2. Immediate containment: immediately upgrade the Agentforce integration user to a full CRM license and assign the Data Cloud architect permission set to restore data access. 3. Long-term remediation: implement license-aware grounding. I would refactor the prompt template to check for feature accessibility before attempting to query a DMO. If the license is missing, the agent should fail soft to a CRM-based answer. 4. Governance fix: build a licensing audit script. Every month, the script should verify that all AI integration users have the correct mix of Data Cloud and Salesforce licenses to access the enterprise data model. Pro tip: license types in Salesforce are functional walls. A platform user cannot see a Data Cloud DMO. Always ensure your AI integration users have the full CRM license tier to ensure they have the total vision required for an enterprise customer 360.
Production Incident 139. Concurrent UI versus AI save conflicts triggered thousands of unable to lock row errors on the case object. Both the Agentforce service agent and human agents were attempting to update the same records in a high-velocity queue. How do you resolve the locking conflict?
Answer: this is a record locking failure. I would resolve the conflict as follows. 1. Root cause: both the AI and the human were trying to update the status field simultaneously. Salesforce locked the record for the first transaction, causing the second to fail after 10 seconds of waiting. 2. Immediate containment: implement field-level governance. I would make the status field read only for the AI if the case is currently owned by a human and vice versa. 3. Long-term remediation: implement asynchronous AI writes. The Agentforce agent writes its update to a pending _action__C record. A shadow flow then attempts the update with a for update wait retry logic to avoid the UI conflict. 4. Performance fix: use platform events to decouple the AI's update from the UI. The AI requests a status change, and the platform commits it whenever the record becomes available, preventing the UI freeze. Pro tip: AI is faster than humans. If they both click at the same time, the AI usually wins the lock and the human gets the error. Always architect a handoff where the AI relinquishes control of the record the moment a human agent accepts the case.
Production Incident 140. Cascading Failure Event Bus Daily Limit Exhaustion, caused by an AI human activity ping-pong loop, blocked all emergency support alerts for 8 hours. This resulted in a SLA breach for a government client and a security risk as the SOC team missed multiple intrusion alerts. How do you recover?
Answer: this is a resource exhaustion cascading failure. I would lead the following high-stakes recovery. 1. Root cause. Agentforce was publishing a summary event for every message, and a human supervisor tool was publishing a monitoring event in response, creating a 2-for-1 event explosion that hit the 1 million event limit. 2. Immediate containment. Immediately blacklist the AI summary event from the event bus and use MuleSoft to bridge the emergency alerts directly to the SOC, bypassing the exhausted Salesforce bus. 3. Long-term remediation. Implement event aggregation. Refactor the AI to publish one session summary event at the end of the conversation rather than an event for every message. This reduces event volume by 95%. 4. Executive fix. Build an event budget dashboard for the CIO. I would prove that by using high-volume platform events which have higher limits for AI activity. The standard event bus is reserved for critical infrastructure alerts. Pro tip: platform events are a shared bucket. If your AI talks too much on the event bus, your security system goes silent. Always isolate your AI activity events into their own high-volume stream to protect your core enterprise alerts.
Category 10 Conclusion. Mastering the Platform Physics.
Architecting for Agentforce within the Salesforce ecosystem is a masterclass in respecting multi-tenant boundaries. As we've seen in these final incidents, no matter how intelligent your agent is, it is still bound by the 10-second invocable timeout, the 6 megabytes apex heap, and the strict hierarchy of object-level security. To succeed at an enterprise scale, you must move beyond the AI hype and master the platform physics. A principal architect ensures that the AI's technical footprint is lean, asynchronous, and perfectly aligned with the governor limits that protect the core enterprise engine.
Part 1 Conclusion. The technical engine is secure.
We have now covered the first 140 production incidents of this masterclass, the complete technical engine of the Salesforce Data Cloud and Agentforce ecosystem. We have explored the war stories of autonomous action failures, ingestion bottlenecks, identity corruption, and platform limit collapses. You now possess the architectural blueprint to ensure your AI stays functional, performant, and grounded in reality. You are no longer just an architect. You are a failure engineer capable of defending the technical integrity of the world's most complex AI deployments.
Transition to Part 2. Moving to the enterprise frontier.
But technical mastery is only the beginning. In a global corporation, you are not just fighting governor limits. You are fighting token costs, security leaks, compliance audits, and boardroom skepticism. It is one thing to make the AI work. It is another to make it enterprise grade. We are moving from the how it works to the how it is governed. In Part 2, we dive into the high-stakes world of AI FinOps, the Einstein trust layer, and global governance. This is where we secure the enterprise frontier and justify the multi-million-dollar ROI of the autonomous future.
Part 2 Roadmap. The Enterprise Frontier Incidents 141 to 250.
In the next video, we will master the final 10 categories focused on governance, FinOps, security, and strategy. Category 11, Prompt Builder Security and Einstein Trust Layer Failures. Category 12, Einstein Trust Layer Compliance Audit and Legal Failures. Category 13, Org Strategy, Security and Governance Failures. Category 14, Data Cloud FinOps and Credit Economics Failures. Category 15, Agent Ops, CI and CD and Org Release Failures. Category 16, AI Observability, Einstein Trust Layer Monitoring and Traceability. Category 17, Disaster Recovery, Resiliency and Core Platform Continuity. Category 18, Migration and Legacy Platform Modernization Strategy. Category 19, Architecture ROI, Licensing and Build versus Buy. Category 20, Conversational UX, Agent Persona and Localization Architecture. The stakes are higher, the costs are larger, and the risks are global. Let's finish the masterclass.
Final call to action. Secure the enterprise.
If you are a principal architect, CTO, or enterprise consultant, Part 2 is where the most critical boardroom scenarios live. Do not leave your deployment at risk by only mastering the technical side. Click the link in the description to dive into Part 2, the Enterprise Frontier. We will see you there to complete your journey to becoming a reference-grade Salesforce AI architect.
The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
For more exciting tips, tricks, and more importantly, for valuable insights of interviews, please share, like, and subscribe to my channel. It has a lot of valuable information about various insights of interviews. It has a wide range of real-world portfolio projects of various technologies for interviews, and it has wide range of most asked interview questions and answers of various technologies like data science, SAP, AWS, DevOps, and full-stack web development, and more. That will be useful during interviews. It has a wide range of most asked interview questions and answers and real-world portfolio projects of various technologies for freshers. For 2 to 3 years, experienced candidates, and for 5 or above years, experienced candidates to test their skills by knowing most asked interview questions and make themselves ready for interviews.